Great.
Nathan, if you want to take the stage, please.
You guys go for it.
I'll go get started.
Okay. So let's see. Okay, so we're filling in a bit. Aaron couldn't make it last minute, and so we're going to give his amazing talk. And it'll be fantastic. We are going to basically talk about, so the Ubuntu community has grown and waxed and waned over the years, and we're seeing a really cool resurgence. And we're also, the Ubuntu Community Council, which I'm on, as well as the Canonical Community Team, and a lot of community members and volunteers have been working really hard to expand and adapt the online community in ways that bring people together and really reflect the Ubuntu philosophy. So without further ado, except I'm going to put on a wireless mic so I don't hold this. And we'll get slides up, so about 2 minutes, we're going to talk about that.
Yes, thank you, folks. And after this talk, we'll have another interesting talk by our very own Simon Quigley. So, yes, why don't we keep going with that? All right. In HDMI, we trust. It's okay, guys. I promise. Yeah, I just want to make sure that the HDMI is working. I don't know what's happening here. This sucks. All of it sucks.
I have an AMD system in my house. Oh, I can't use that. Wait. Run into them on our IRQ. Yeah, I know. You haven't been active on IRQ.
Somebody kind of check your arms. Stand by. The display is picking up.
Yeah, so we may need AV help for the projector.
Really similar to S-Link. He's a really old man.
You guys don't need for a little more, do you?
Probably not.
Need the remote?
Seems like it.
No. Okay.
All right.
Okay,
What was the Wi-Fi
okay, so now we're good to the button. Yeah.
Password is penguins, everyone. You need Wi-Fi. Don't use your mobile hotspot.
There you go. You're all set. So,
All right. Talk till 10:45? Okay, that'll be fine. Hello, can everyone hear me? Thumbs up? How do I sound in the back? Thank you, great. All right, okay. The HDMI works, which is not common occurrence on this laptop, so I'm happy. DisplayPort? It does not. Yeah. Okay, slideshow. All right. Okay, let me get adjusted here. How do I clip this thing on? There. And how do I turn it off so I don't accidentally get hot mic'd or something?
it's there.
This one?
Switch.
Okay, sweet. All right. Thank you. So, hello, everyone. This is first talk to give here. It's a little bit interesting. So originally, if you actually looked at the schedule, you would see that it would be originally given by Aaron J. Prisk. He is a Ubuntu member, and he's also on the Canonical community team. So basically, his role is that he is very active with the community. I think there are multiple people here: myself, Nathan, Simon. Pretty much anyone that has some kind of exposure to the Ubuntu community has kind of been able to experience the work that him and his team have been doing, and really working on kind of improving the Ubuntu community for the better, and just kind of being able to support. So his original talk was going to be creating a community for the next generation. So one thing that I first wanted to do here was just kind of introduce Aaron. So I did give a little bit of a kind of overview of who he is, but Aaron Prisk, that's a photo from him at the Ubuntu Summit, which he helped organize. He's on Launchpad, and he was on the SCaLE, returning UbuCon at SCaLE organizer committee this year. He has been very instrumental. He was doing a lot of work, kind of going back and forth with the SCaLE organizers, really, kind of collaborating and working with that team. He's a super great guy and all that. Unfortunately, he had an emergency, and so he was unable to make it. But I just want to take this time to really, kind of highlight, such an impact that he's had, and kind of understand that without him and all the other organizers, maybe toot my own horn a little bit here, but we wouldn't be able to, bring this event back to SCaLE and be able to kind of be in this room with you all here today. And so if you're kind of interested about what the picture is, Aaron and I, we were kind of hanging out one day, and we decided we wanted to play with an AI image generator. So he decided to kind of go for the futuristic steampunk look. And if you're wondering why he has a turkey in there with him, he actually has a pet turkey that he named French Fry. So if you go up to his farm in rural Pennsylvania, we actually live kind of close to each other, considering I'm based out of the city of Pittsburgh. He has kind of, he's a bit like Joe Exotic, but a lot less toxic, as I put it. So he has a turkey. I think he has some emus. He has a couple horses as well. Very interesting guy. He's kind of who I want to be in 10 years. So yeah, now that I've kind of done a little bit of talking about Aaron, why don't we kind of go ahead and highlight who is giving the talk here. So Nathan, if you want to kind of take point, introduce yourself real quick.
So this is my 16th SCaLE, so everybody knows me. But for the benefit of the, thank you, the benefit of the live stream and new people, so I've run the Ubuntu booth for 16 years now, and we've been doing UbuCon for, as I just said, we forgot to count, but about 10 or 11 years. I was involved in the Ubuntu California local community team, LOCO for short, because we're crazy about Ubuntu. And I ended up on the LOCO Council, helping local community teams around the world, and I'm currently on the Ubuntu Community Council, which means I get to work with cool people at Canonical, whose job it is to help me figure out what we can do, how they can support, how Canonical can support events like UbuCon, the booth, and the speaker track, and help arrange, usually Richard and I arrange the talks, and he's really good about working with getting speakers and helping figure out what's the angle we want to focus on this year, any year. And then I work usually a little more closely with Canonical specifically. And so I've had the deep pleasure of working with Aaron for a couple of years now. And so I try to kind of put all the pieces together with Richard's help and a lot of other people's help, and get volunteers for the booth, and then sit back and, well, I work at the booth, but basically sit back and watch all the cool things happen along with all of you. So that's why I'm so happy that you're all here, because everything I do for the Ubuntu community is in support of the community, which is you guys as well.
Thank you, Nathan. And so now I'll introduce myself here. So I kind of like to consider myself a relatively new member to the Ubuntu community. So I guess a little bit of an origin story about myself. I actually didn't start learning how to program until I was 17 years old. And why I started learning to program, it was because my aunt gave me a Target gift card for $20, and using that $20, I bought myself the book called Coding for Dummies. And now I'm standing here organizing UbuCon at SCaLE. So quite a bit of a, I guess, say, ascension there. I like to look at that. At that point, when I was 17, I was still very much interested in pursuing a degree in sociology. I like to bounce around a lot. Kind of giving some further context, I went to college, kind of started out as a computer engineer. I really wanted to do computers, but I found that I didn't really enjoy kind of the hardware and sitting at a cubicle and all that. And I kind of wanted something more interesting and challenging where, essentially I have to, be someone who understands how computers work, understands how to write code, how to develop applications, and kind of come out and go out and speak to people and understand what their challenges are, understand, kind of what problems that they're currently having, how are they trying to solve the problem currently, does the solution even actually exist, and how can we kind of use and leverage the power of technology to kind of make a solution that's better for everyone. And so I was originally, then at that point, interested in pursuing my doctorate in informatics, so kind of understanding like the science of data and all that. But then, kind of interesting, one night I had a long conversation with myself and my now fiance, and also, inflation was bad at the time, and decided that I wanted to instead go into industry. And then at that point, I was installing Ubuntu, and I saw "We are hiring" on the website. And so I was like, oh, this is kind of interesting. So I clicked it, and next thing you know, I was like, I don't know what to expect. And then I actually heard back from Mark Shuttleworth. So I was like, all right, I gotta get on that. So, and basically now here I am. And so you might be wondering on the slide, what does the not-so-ancient elder of Ubuntu HPC mean? So at Canonical, my responsibility is kind of working on the supercomputing and high-performance computing team. Traditionally, we found that Ubuntu is kind of underrepresented in that space. There is a bit of Debian and Ubuntu deployment, but it currently is largely mostly enterprise Linux and other, custom distro builds. So, I kind of, taking the problem in charge at hand, decided that, I wanted to create a community around high-performance computing on Ubuntu. And so we ended up forming a community team. I guess very straightforward, Ubuntu HPC. And then the reason why we call ourselves the not-so-ancient elders is because most of us are not that old. So myself, I was born at the turn of the millennium, 2000, so it's very easy to figure out how old I am based on what year it is, which is quite convenient. So yes, and I was on the UbuCon at SCaLE organizing committee. It was very fun being a part of it. I was actually invited to do it with Aaron. I had helped out with the 2023 Ubuntu Summit. And at that point, I really wanted to work with it because, it was kind of an opportunity for me to really engage with the community. I like Nathan, so I like to spend time with Nathan. I like to work with him. So we would have a call, every other week. I think George as well, Richard, really great set of guys, who have been stalwarts of the community. Nathan's been around for 15 years. Like, that's really impressive. I was like 9 years old at that point, so sorry if I aged you a bit. But, it's kind of like people who I've always really looked up to and thought, are just amazing people. And it's like, oh, I have this really great opportunity to kind of now engage with these folks. So now that we've kind of gone through the introductions here, one thing that I really kind of want to say is then look back at the title of this talk, which is, so what does it mean to create a community for the next generation? And so this was a very interesting conversation that I was having with Aaron, coming from my perspective of someone who was born in 2000. Very easy low-hanging fruit there is that I don't really like using IRC that much. I find it quite dated. I'm one of those cool, I guess young kids who doesn't know how to spell and likes having an edit function and all that. And I like being able to embed videos and send emojis and format code using Markdown and all that. And so we kind of got started, discussing, like, what does it mean to create a community for the next generation, and how do we kind of get the next group of individuals coming up, through school, through university, through industry, and how do we kind of make them interested in contributing to open source and being a part of the Ubuntu community? So. And
there's another issue, too. So, for example, though I haven't used it lately, I love IRC. I think it's fine. I love emotes. If someone gets out of line, you just slap them with a trout. It's just, there's a community there. It's been around since '87. I've been using it since '94. I'm comfortable. I don't understand social media. I can sort of interact with it. I can use it, but it's something. And then some of the bird site exploded, and now in the shrapnel and debris, there's other sites, and there's Federation, but not. And so, so I had a grasp of social media, and now it's much harder, and now I don't. So. Well, I don't love IRC. I do like IRC. I like mailing lists. I like lots of things. Some of the new stuff, I don't know. So now there are two things to balance because we all need to be in a community. We all need to talk to each other or we're not a community. So that communication thing is not, well, we'll just grab the latest apps. It's a lot more difficult than just that. And so that's one of the reasons that the Canonical Community Team and the Ubuntu Community Council have been focusing on this issue of how do we build this next generation of the community platforms that can keep going and thrive into the future.
Yeah, and I think that's a great point. And you might even say, like, what is like the impetus for having this conversation? Why would we say it? And let's face it, Ubuntu is turning 20 years old this year, so woo! Still not old enough to buy a drink in the US, unfortunately. Can buy a drink in Europe if we go over there. And we also can't rent a car without a fee, which is very difficult if you're going to a city where the airport is like 20 miles away, which I cannot stand. That's like Pittsburgh almost. It's impossible to get an Uber or a bus into Pittsburgh proper from Pittsburgh International Airport. Yes, so, kind of the reason of saying like, Ubuntu is turning 20 years old. Why do we need to think about this? Well, I think 20 is a nice number to kind of look back, take a time to look in the mirror, that picture there where it's supposed to be a mirror, kind of looking up at the clouds, symbolism there, abstract a little bit. This is a great opportunity for us to really take time and look back and reflect on kind of some of the successes that we've had, with the community, some of the challenges that we've had, and honestly, also looking at some of the failures that we've had as well, and kind of looking at that and seeing like, how can we learn from that? How can we come back and build better? But then I also think that it shouldn't just be all doom and gloom, kind of being like, oh, I can't believe I posted that online when I was 15 years old, or something like that. But also look at, kind of like, this is really a great opportunity for us to look forward and kind of think to the future of like, where do we want to take this thing? Where do we want to take community? How do we want to, be able to build a successful community, kind of keep the momentum going, but also make sure that, we're creating new opportunities.
Yeah, one of the tragedies for me as a writer, but one of the lovely things about me is everything else I am, and probably the world at large, is that nothing I wrote and posted when I was 12 and 13 on dial-up bulletin boards exists anymore. So, silver lining.
Yes. And so then, kind of thinking about the community of the next generation and thinking to the future, the question that we should really ask is, what should the next 20 years of the Ubuntu community look like? How do we want it to take shape? What do we want to accomplish? What do we want to keep doing? What do we maybe want to stop doing? Obviously, certain things considered, some things are feasible and attainable, and then other things would be nice to have. But it's a great time for us to really look and say, like, the world's changing. I mean, just look, for example, of like ChatGPT. Companies want to cram AI into everything now, so that's very fun. And then also kind of looking at like kind of as these trends in technology change and these trends of like maybe the evolving definition of what it means to be open source. How can we kind of be able to adapt this into the community and kind of continue this natural healthy growth?
Right, and the important thing to know is it's not we're not let's make a 20-year plan, but let's make sure as we reflect, it's been 20 years, we have all that experience, what have we done, what's worked, what hasn't, and what new technologies are coming along now, and how do we make sure that we are evolving and on that right course, because in 20 years from now, the landscape will be completely different. We don't have, it'll be a Discord, but in our, retinal implants that we see all the time or something, right? We can't plan for that, but we can make sure that we are not stagnating, not standing still, that we are learning and adapting, and not just serving the current community members better, but also being inviting and serving new members as well.
Yeah. And so now this might be a little bit abstract here, but I definitely like symbolism. And so effectively what this is a photo of is one of the 3 rivers in Pittsburgh. So if anyone doesn't know this interesting little factoid about the city of Pittsburgh, which is where I'm from, is that we have over 400 bridges. We have the most bridges in the world in our city. That's mostly because we have the Allegheny, the Monongahela, and the Ohio River, and used to have very strong, manufacturing steel industry, and so, needed a lot of bridges to help move all that coal and steel. And so, why did I think that, a photo of, say, the Pittsburgh River with all the bridges crossing, traffic's a nightmare, by the way, but that's not the point, is, what's the importance of this? And I think, one thing that we should really focus on for the next, say, in the future is how do we build bridges? How do we create bridges that allow people to get involved in Ubuntu, and how do we kind of reach out to communities that maybe traditionally haven't been involved as much? So, you can kind of look and see like, oh, we have like the techies, who like the packaging and all that, and kind of like the really, code and engineering aspects of things where it's like, we just love the raw technical aspect, but, how do we kind of create opportunities for, say, like local communities? How do we create opportunities for schools? How do we create, opportunities for, say, even companies to be able to get involved in the community and kind of be able to contribute and be able to kind of spread the philosophy of Ubuntu. So one thing that I just really kind of want to dive into and kind of how we're having this conversation around building community for the next generation is kind of look at a lot of the recent successes that we've been having with the community. We've been doing kind of a lot of work, at least over the past year, kind of helping to adopt new initiatives, adopt new platforms with the community, and just wanted to take a chance to really kind of reflect on that and understand what went well and kind of like how this is good for us going forward. So I think the first thing that I really wanted to touch on, and probably also my most popular post on Mastodon by a mile, is the recent adoption of the Matrix platform for the Ubuntu community. So if you aren't aware of what's been going on there, basically over the past couple of months, we've really been working to kind of make Matrix a first-class platform for communications within the Ubuntu community. Why was necessarily impetus for this? Well, we looked at IRC and kind of saw some challenges we were having there with the chat platform, and we kind of looked and started seeing where are other places that people kind of want to have synchronous communication or even asynchronous communication. And so we went out, looked at a lot of possible chat clients. So for example, there's Slack, Discord, all that. But the real issue with a lot of those is that, yes, they have the features that a lot of new community members want, like editing, text formatting and whatnot. But the problem is that none of them are open source. Discord isn't open source. Slack isn't open source. Telegram's also not open source. That was a popular one too that people liked using. And instead, we kind of then looked at Matrix and kind of the ecosystem around there. And what we really liked is that it kind of was able to present the features that folks wanted from a chat client, but also still kind of was in line with our philosophy of it needs to be open source, and we need to be able to be contribute to it and kind of feel like we're helping push open source forward. And so we started adopting Matrix. And Nathan?
Yep. So the interesting thing is that a lot of the planning for this year for SCaLE, it actually took place on Telegram, and a lot of other planning for the Business Summit all takes place on Telegram. And so you might ask, well, why would Ubuntu community members and organizers and so on, why would you choose Telegram? And the reason is because when the Ubuntu phone came out, a Telegram client came out really quickly, and so everyone Canonical was dogfooding the Ubuntu phone and the mobile OS, and that's how I eventually decided to grab Telegram, because I wanted to talk with them and get all the inside scoop about the phone project and so on. And it was very useful, and it was one of the easier things to talk my friends into, because of course we're all using text messages and Facebook, and I think Discord was still early on, and lots of things. I'd be dragging and screaming to Discord by my kid and his friends, and so on, my friends' kids, so just to play Minecraft. So Telegram kind of grew because it was there and it worked. It was really decent. It has a lot of great features. In fact, they've really pushed the last half year and got some really good features. But in the end, a lot of people don't want to use it because of the company who makes it, or because it's proprietary, and so on. And so we had a chance to look at what are the alternatives. And so yeah, almost all discussion has gone now from Telegram this year on Ubuntu to Matrix, as far as the high level, we're making stuff happen, making plans. And so that's why Telegram, and that's also why Matrix. We need to have something like that, and Matrix with its federation and so on, home servers, you control your data, it's open source. It just made a really good. It was a really good proposition, and it's getting to the point, client support and so on, that it's very usable. Whereas a couple of years ago, I didn't find it so much. So. Plus, no one else used it, so.
Yeah, that was a big thing. Folks didn't use Matrix for a long time. But one thing that was very, I think, unique about this, transition to Matrix is that, when we kind of started moving over to it and adopting it as a mainstream platform for communication, we found that not just, Ubuntu as an operating system itself was, the only community that kind of moved on to Matrix. So, for example, you can look at, maybe say traditional things like, support. That's a big one. A lot of folks, like support. You could say, oh, when we adopt Matrix, we're just creating a support channel for the operating system, which is not fully what happened. And actually, what was interesting is that we were able to bring over, say, Ubuntu as an ecosystem. So, like a lot of projects that, you can maybe consider friends of Ubuntu or kind of adjacent to Ubuntu. we were also able to kind of bring them over, and they were very interested in adopting Matrix as a mainstream chat client too. And they really looked at it as kind of an opportunity for us to all kind of fly under the same banner of Ubuntu. And so actually, if you do go on Matrix, if you access our Matrix space, you'll see that it's not just, kind of operating specific desktop specific stuff, but actually there's a lot of sub-communities in there as well. So for example, just pointing at some of maybe the logos there is that we have a pretty active Snap community on Matrix. So for example, the Snapcrafters are on Matrix. We also have, Snapcraft or the StarCraft team as well. They're sitting up here. And then, also Snapd as well is on there. If you're kind of looking at that little squiggly snake thing on the far right side, sorry, or actually now it's the left for you folks. That is our Juju community. So we kind of have the...
You meant stage right.
Stage right. Thank you, Nathan. So we also have our Juju community. So for that as well, it's kind of more the DevOpsy cloud-focused community. So you could say like identity. So like LDAP. That's just basically the easy example. We also have like observability. So like Grafana, Prometheus. We also have like Telco. And then some other communities that we have as well is like OpenStack. For those of you that don't know, Ubuntu is very used in OpenStack, and we have a very vibrant OpenStack community, so they're there as well. We also have, our local communities as well coming on Matrix. So for example, we have like Ubuntu Portugal, we have Ubuntu Korea, and a lot of others starting up as well, like Ubuntu United Kingdom. And then we also have kind of the security-minded folks as well on Matrix. So for example, like, just people who are nuts about security, love security, want to help make the world a more secure place. They're on there as well. We also have Ubuntu Touch, and then some other sub-communities as well. Like our Ceph folks are on there as well. They provide lots of help around using Ceph. So that was the great thing about Matrix, is that with kind of that space functionality, or maybe similar to say like discourse groups, is that we are able to effectively create multiple channels and sub-communities that allow kind of all those rooms to be in the same place. So if somebody says like, hey, I want to join Ubuntu on Matrix, you'll be able to just kind of have a one-stop shop for all the open source communities that are a part of us.
The nice thing about that too is that, and what this sort of, to give an overview of what the effect is that for internal communication, Canonical, I think, use Mattermost. And so, for example, I'd be at a summit or something, and there'd be a group, and they say, I'd pass by, and someone would say, oh, hey, we were going to have dinner or something. I was looking for you on Mattermost. Why can't I find you? And I'd say, well, because I'm not on Mattermost. And they're like, but you work for Canonical. I'm like, I do not work for Canonical. I'm like, but you used to? I'm like, no, I never. I do this for fun. I'm a volunteer. So, they were on a completely different platform. And so part of this adoption of Matrix on their side, that I have absolutely nothing to do with this, because once again, I do not work for Canonical. Not that I wouldn't, I don't. Is that when that communication gets to Matrix, and then all the employees are on Matrix, and all the community stuff have rooms on Matrix, all these projects and so on, because the people who have been working on Snaps or Cloud or Juju or any of the other billion of things that make up Ubuntu, and they're getting paid to do it, and they're working on it, they are also they've always been very accessible, very open to interacting with the community. But they were working every day for work on a different platform. And so now, with them all being on one platform, it's not just the rock stars like Ken, for example, who's just always responding on Discourse, on the Community Hub, and so on. But also a lot of really hard-working engineers who just didn't consider it, that they're working, they have a job, they work really hard, but now suddenly they're on this platform, they can see the other rooms, they're exposed to the community, and they're starting to contribute, and they're being more open, realizing, oh, hey, we're all working the same thing. And so I have heard rumblings early on that that was something they were seeing, and one of the goals to make sure that this transitions is to make sure that some engineer who just looked for a job and is doing really hard, important work can easily see that they're actually part of a global community of really, really, really smart people as well, and opening up those communications so that it's not Canonical and a giant wall and Ubuntu and a giant wall and people who use Ubuntu. We're all one community, and that's one really nice advantage of using Matrix that we started to see and pushed for.
Yeah, I definitely agree with that. Once we started, adopting Matrix, there was a large push internally inside Canonical to start using Matrix as kind of the main communication platform. And part of the reasoning why we really wanted to do that was because there's been a really strong push to kind of be more community focused, more engaged with the community, and kind of encouraging engineering teams to think about the community and kind of create a place where it's easy to get in touch with them. Because yes, it is very hard when it's, you're trying to give feedback and you're trying to, ask questions, or you're trying to contribute, and then it's kind of like you're basically speaking to a brick wall, or maybe say even a black box, where you basically just punch something in, and then hopefully, in the private, company chat, it's discussed. But now with Matrix, a lot more conversations can happen out in the open, which is definitely a great benefit.
Yeah, the Ubuntu Community Hub, which runs Discourse, really had that effect as well. And so Matrix is really a force multiplier for that. So on the community side of things, I'm really, really happy to see that, because I know how awesome everyone at Canonical is, and now a lot more people can too. That's an opportunity that Matrix and Discourse have allowed us.
And so now that we've spoken about Matrix a bit, the next really exciting thing that I kind of wanted to highlight that we've been working on this year is really kind of working to reignite locos and the council that's associated with that. And so if you look at the little graphic here on stage left of the slide, thank you, Nathan, you will see that we've really started having a lot of communities either reemerge or really start bouncing back from 2018, the pandemic, where everything just kind of really got put on pause. And so kind of wanted to highlight a lot of the local communities that we have starting up or really starting. So one exciting one that we have is Ubuntu Nigeria. We got some really passionate and excited contributors that came to the Ubuntu Summit in 2022. And they were like, we want to start a loco. And it's like, great, go do it. And they did. And they actually recently had an event. If I remember the name correctly, it was called Ubuntu Meetup Africa. It was hugely successful. And then one of their main organizers, too, made some really amazing artwork for that event and really introduced actually a lot of people in their community to Ubuntu, which is great. And then some of the other exciting ones that we have is like our Korea community. They're doing UbuCon.
Well, before
Korea.
we move on that, because Korea are rock stars, and we could cancel the next talk and talk about all the great stuff they do. So thank you to them. So fun to meet them at the last two summits. But Ubuntu Nigeria came in. We're really excited. Got support from I think Aaron and Mauro on the Canonical Ubuntu community team, and got some support, got some pointers, and not only was this a giant reason to say, the local community team effort has waned and kind of gotten really slow, and we want to restart it, and that was definitely an issue for the community council. But in addition, in Nigeria, I don't remember the leader's name. He went in, he got a meetup, got a lot of interest, did some talks, and as far as I know, did the first Ubuntu Install Fest ever in Nigeria, and it was a massive hit. And you would never know this is a new team because the artwork looked great, their production value was fantastic, the presentation was great, and so that's a sign of what people can do. They want to volunteer. They're excited about any topic, including Ubuntu. Because this was ramping up and this was something we knew we wanted to do, the community council got together and was able to reform the Ubuntu local community council, so community council focuses on a lot of things top level. The local council members, I've done the work before. It's basically you just focus on those issues of support and encouraging things and helping guide people to resources for sponsorship and other things. How do they get a tablecloth? How do they get swag? Or how do they get the logos to print banners? And so we've been able to put in place a council who, in their just first couple months of re-existing, have done really hard work in getting people re-engaged. So thank you to all of them as well.
Yeah, they've definitely been, a huge, massive help, and it's really great to see because, I want to form my own loco as well. So we do have the Ubuntu Pennsylvania. I know that was a pretty large community. I still see them on Launchpad. It doesn't seem like they've had a whole lot of activity. But, Aaron and I, as Pennsylvanians, we really want to bring it back. I also think a very active Linux users group as well in Western Pennsylvania. So kind of exciting to see, kind of a lot of folks around the world, just kind of feeling excited and, empowered to be able to, start local communities in their area. And so the last thing I really wanted to comment on this slide here is that QR code there. That if you scan that using your phone, that will take you to the Loco Council matrix room on the Ubuntu matrix. So if you have any questions, maybe out loco, like maybe if you were a past member or a past leader who wants to like get restarted, or you just have any general questions about starting your own loco or just getting involved, that's a great opportunity to just really have that synchronous, start that communication. I think they would definitely be happy to see that folks are interested.
And so Ubuntu Korea is also not only started, they have their great UbuCon events usually in Seoul or in Korea. They've also worked with the other Southeast Asian teams to help them put on events. There's I think it's UbuCon Asia, yeah, that's right. UbuCon Asia. That's they were in Jakarta one time. I think it's in India this upcoming year. They've been working with all those other teams and helping support them. And the Ubuntu Peru and Colombia and I think Venezuela have worked all together. There's a UbuCon Latin America. That's a cross-loco, international effort of a lot of volunteers. So it's not just I helped set up a new council and they can help people. It's not just that. It's people on the ground who, like people who come to SCaLE, for example. You can, if there's a university near you, talk to a professor or advisor, see if you can do an install fest, or see if you can do a presentation, and come into an IT class or something. It really is the grassroots efforts that helped spread Ubuntu that made it popular in the first place. Locos are just a way of kind of, pulling resources and advice, and so we're trying to get that spread again and active again like it always was.
And so, kind of on the topic of locos and organizing events, it's really great that you bring up like UbuCon Korea and UbuCon Asia, kind of these community events, and even UbuCon at SCaLE. Another recent success that we've really had is kind of starting the Ubuntu Summits. So as I kind of like to look at it, obviously I wasn't around then since I was still in high school, but there used to be sorry Ken, there used to be the Ubuntu Developer Summits, and then starting back in 2022, it was decided that we wanted to start doing those again, but this time under a rebrand as the Ubuntu Summit. So if you look at stage right here, kind of the farthest right there, you'll kind of see the castle there. That is the logo for the Ubuntu Summit that was held in Prague in 2022. It was the first time that we kind of put on a style event like that. And it was very interesting, fun time. And then kind of then in the middle there, this was our latest Ubuntu Summit. That was in Riga. That event was a smashing success. And if you're wondering what the logo specifically is, there's a freedom monument that's in like the town square in Riga. And so it's kind of dedicated to the pride, and the sacrifices of the Latvian people. And so we felt that when we had the summit there, we really wanted to highlight that local community that we had there at Ubuntu Latvia. And then kind of if you look at stage left here, you see a bit of a smirk emoji. We'll have some exciting updates coming out soon about the Ubuntu Summit 2024. So definitely stay tuned for that.
yeah. I think we should get Pasadena, right? Well, I know it's not Pasadena this year, and I'm not allowed to say, I'm not allowed to know, actually, so we won't talk about that. What we will talk about is, so in Riga, I ended up giving a talk, and I won't repeat it here because it's online and needs view counts. Welcome to Ubuntu Summit. But because the first one, so I get invited, which is great, and they fly me out there. It's a perk. And they brought community leaders from all over the world all in one place. In a way that SCaLE did sometimes, from times when just busy years, but in a concerted effort to get people all in one place because the talks are great, the hall room talks is fantastic, and going out to the bar at the hotel after, going to the restaurant where you just gather and get to know each other, and then you go off and you're on emails and matrix and so on, and you know each other, and it builds those bonds. But Ubuntu Summit, Ubuntu events are very, very, very much like SCaLE. Nobody believes when I say how great SCaLE is, and then Ubuntu. If I try to describe Ubuntu Summit, no one believes me. We all kind of know what it's like here. And so, after the first one, I had some time to speak in Riga, and so I spent a lot of time talking about community and how we all all build together, like I've mentioned those points here, but I also specifically mentioned UbuCon at SCaLE because to me, this is the perfect way that these conferences should feel like. And I go to Ubuntu Summit, and it's this exact same friendly feeling. And yet, I think that a lot of the tech events don't feel that way. It's like a big family. It's like going and spending a weekend with 800 of your friends. Ubuntu Summit feels like, and we know here at SCaLE, and Jason doesn't know yet, but will by the end of the weekend. It's like hanging out with a bunch of 2,000 of your friends, 3,000 of your friends. So the Ubuntu Summit is a way, just like you all come to SCaLE and see all the communities and all the people working, Ubuntu Summit's a way that people can really come in and not just see the people that they interact with, but also all the cool different projects that are going on in the Ubuntu community. And that camaraderie that kickstarted Ubuntu Nigeria, and I think the Korea team decided to go bigger with their UbuCon Asia, and so it's all a work in progress. But the Ubuntu Summit's really exciting.
Yes. So a little bit about that too, and then something else that we wanted to highlight as well is new community teams. So getting a little close to the end of the allotted time slot that we have here for this talk, about 15 minutes left, but just a few more slides. 10 minutes, yes. So we have about 10 minutes, 15 if we really want to, mess with Simon. But what is it? Yeah, so we had new community teams, join us this year. So for one, this was one that I helped start. It was the Ubuntu HPC. If you don't know what HPC is, it's supercomputing. And so we had a lot of folks who were kind of in the Ubuntu community who were very interested in kind of, using the distribution for petascale, exascale computing. And so, basically we decided to kind of all unite under this one banner of Ubuntu HPC. And it's been very fun. Coming up on our 1-year birthday here, first few weeks was learning how to walk and all that. But it's definitely been a great time. And, we actually have weekly community calls now that are open to the public. So, Wednesday at 17:30 UTC. If you want to talk with some fellow supercomputing nerds, we are on Jitsi. And so then the next community team over here that we have as well is our Rocks community. And so they're very focused on using Ubuntu for container images. They're also a very great group of individuals. They have some of the star crafters in there. So for example, you have Snapcraft, Charmcraft, and you also have Rockcraft. And so they really enjoy making good OCI images for different applications, so like databases and all that. And then they have this really awesome utility called Chisel, which is great for kind of taking apart Debian packages and really kind of fine crafting your containers so you can get a minimal, small image as possible. And yeah, I think that's pretty much it. I forgot to put the question mark there. But if anyone has any questions, we have about, say, maybe 5 minutes here. So if anyone wants, feel free. Also, we do have some, Ubuntu merch over here. So we have stickers for Kubuntu, Circle of Friends, Mantic Minotaur. We have some notebooks and coffee cups. So, feel free to walk on by if you want to pick some up while you're on your way out. But yeah, any questions? Yes.
Let me, for the AV,
Yes.
let me actually do my thing. We were trying to get that great cube mic next year.
Yes. No, we don't.
So
Thanks, Nathan.
I'm not in charge of the Ubuntu Oregon logo, but how would we go about getting that on Matrix?
Yes. So if I understand your question correctly, you're wondering how you get your loco community onto Matrix, correct?
Correct.
Yes. So in that case, if you want to pop into the kind of loco council Matrix room, you can send a message there saying like, hey, I'm from X loco. I'd like to be able to go ahead and create a room. And then pretty much all of them actually have the ability to then go into the Ubuntu home server and create a room for you. And then they can kind of put you in it. They can give you moderator powers and all that. And then we also have some other utilities as well, like a moderation bot that helps protect all the rooms on the server.
Yeah, I think there's a bot. Wouldn't there be the leaders of the logo I'd have to go through, though?
Yeah, preferably. And so you can poke them, for example.
Wish I knew who was leading that thing.
If that's a problem, then you can contact the Ubuntu local community council and say, I need help finding the leadership. Maybe if you're interested in taking over, if everyone's not there, and you can also get a category on the Ubuntu Community Hub discourse and the Matrix room. It can all happen at the same time.
Yeah, the only reason I say that is it's basically.
Right.
Yeah, so
He's just recently on. Here, I'll repeat this. I would talk to Walter Lapchinsky. He is a former member of the Community Council. He is on Matrix now, so we're looking to, put a lot of this on Matrix. I would say talk to him and see.
yeah. So yeah, and then if you are, that does bring up a good question. So it's like if you have a loco, I do appreciate that folks are cognizant that like, oh yeah, there used to maybe be a loco in this area. Don't necessarily want to just, say, get out of here, Thanks for the work, or thanks for all the fish, if you read Hitchhiker's Guide to the Galaxy. But, we are working on, with the local council, a recertification process. So if you are interested in starting up a loco and you can't get kind of in contact with previous leadership and whatnot, the council can kind of help you out with, initiating that process of takeover. So.
I've got a question. I'm with the OpenSUSE community,
Yes.
but I'm kind of curious, how do you guys deal with bridging the separate communities like Matrix, Discord, IRC, Telegram, and so on? Because I know it's been fractious in our community, especially like with the old neckbeards on IRC and that fancy new Discord Matrix thingy. You're like, noise, oh no. So how do you guys manage that as the Ubuntu community?
Yeah, so you actually do bring up a really good point. Sometimes, bridging's always been a bit of a hot topic. Some folks that I talk to are like, just don't. And then others are like, oh, it works. And so, for example, one thing that we've really found that's helpful is like bridging, say, Telegram to Matrix. So we have a lot of communities, especially for like the summit. Telegram's mobile client. It's very good. I quite like it myself personally. And so there is, I think it's like t2bot.io. It's very helpful for kind of bridging. There's some technical challenges with that. Obviously, there's like a bit of lag. But, we've kind of found with bridging, the big thing that just really helps is either A, saying like, having clear expectations like, okay, if you want to bring your Slack community, that's probably not going to happen because the Slack bridge doesn't really work that well. IRC, we've bridged a couple of those communities. And then one thing that we've also found that's really helpful is just kind of explaining the benefits of Matrix. A lot of folks, kind of when you introduce something new, change is uncomfortable. But when you show them like, hey, like you have this problem, maybe one thing where it's like people just like dump stack traces in IRC or something, and it's like really gross to read and you lose it. We just kind of find like, oh yeah, it's really nice. Like you can just add like the 3 backticks and specify the language format. So we found that like we don't really want to use bridging all the time because it sometimes doesn't really work well and it kind of degrades the experience on those previously existing communities. But we also find that kind of first talking to those communities, kind of gathering, kind of a summary of like the current problems they're having, and then seeing how we can kind of, curate their Matrix experience to solve those challenges. We find that really helps with getting folks to accept Matrix as a chat platform.
And the other thing, I think, more broadly to the point, so we have an Ubuntu IRC council that deals with IRC governance and the policies and procedures and who gets a room and who doesn't, and there's infractions and manages bans and all those IRC things, right? Some of whom are just as capable on the new platforms, Matrix and so on, some of whom are not and have no interest. And so the Ubuntu Community Council approached them and we talked about creating a, oh gosh, I think it's a communications council. Is that?
Yes,
yeah.
yes, Matrix Council / Communications Council.
And so that kind of not just deals with Matrix, but also, communications with IRC, with forums. But there are groups that, that already are in charge of those. So we get a representative from each one. And so now we have a group we have the focus groups that can deal with our legacy platforms, but we also have a way that we can deal with what are the other platforms we want to identify and work, and when do they bridge and how they work together. And that allows the people who love IRC to focus only on that while still being a part of deciding where we take things in the future. So that's. Yeah, so we've
Yeah.
had better communication between those different teams, and they're not isolated, and they make those together. And it's actually, we were like, how will this work very well? And in the Ubuntu spirit, it's actually worked beautifully, and I can't wait to see what else comes out, because I need recommendations for these things, because I'm old and I don't know. So I'm not qualified.
Yeah, and
So
yeah.
that's our time. Thank you all so much for being here.
Yeah, thank you.
Thank you for him. That's a great first talk.
Thank you. Thank you.
Yeah. And thanks to Jason for his amazing talk.
Thank you for bearing with me. You know, I know when Simon, if you want to start coming up here, I just want to say one more little thing. But what was it? When I heard from Aaron that he wasn't going to be able to make it anymore, first like sheer panic, came over me because like Aaron used to be a K-12 director, and you can tell because I just always trust him with everything. So I'm just like, man, you got me covered and all that. So when I found out that he really needed some time to focus on himself and recover, I was like, I still think like the content that you want to deliver in this talk is really important. And obviously, maybe he probably could have delivered a little better because I had to make some slides last minute. But I do appreciate the work that he has done, the community team has done, even the community council, and the community at large. And I think it's important that we kind of take some time here today to really kind of appreciate the work that you all have been doing. So thank you.
I think Jason did a great job, and the fact that he was helping around the background let him just jump right in. So even though it was a short notice, it's been seamless, and Richard and I were never worried one bit. So a couple minutes, next talk with Simon. Thank you.
So if you want to grab some merch, feel free to come up. We're going to give about like a 5-minute break before we start the next talk. Thank you everyone who came along. Feel free to grab one.
Great job.
Thanks. I think I'm gonna have to go get
How do I use one of these?
just put it.
Is it like?
There's a snap that goes into the jack in the back of your skull. Did you not get the jack? They embed those.
All right, Simon, stand still.
Yeah.
All right, so put those on your ears. Don't freak out.
Ah.
And then I clip this in your pocket. I'm just gonna pickpocket you real quick.
Okay. Cool.
There we go.
All right.
Do you have slides, or are you just gonna talk?
I'm just gonna talk.
Okay, I'm gonna leave my computer at just so we don't.
I will say this, that would be sensory overload for me.
How? What?
Oh, yeah, thank you.
Mic check 1, 2.
So for our next talk, it is my honor and privilege to introduce the famous Simon Quigley. No, sorry, let me check my notes. The infamous Simon Quigley. And his talk is called Open Source is Not Just Code. Simon.
I tried to write this talk a couple of times. I tried 1 time, twice, 3 times, and I just couldn't get it right. So I'm going to speak just mostly off of my notes right here. On December 27th, this past year in 2023, I published a tweet, and I'd like to read it. Open source is more than open code. It is open collaboration and open community. In open source projects, you find a variety of contributors. Some have been around for decades, others have been around for months. Some are paid for their work, others do it out of the kindness of their hearts. Some people are just starting out in the tech industry and need a place of belonging. Others have been in the tech industry for decades. Given these facts, it is important that everyone works well together when the opportunity to accomplish collaborative work presents itself. An often forgotten mantra in the Linux community specifically is know your audience. Understanding who you are talking to and why you are talking to them, is as critical, if not more important, than the message itself. People lose focus. It can be easier sometimes to tell someone to just RTFM or ignore them, because if they would just DuckDuckGo the specific way, remember that you too were once that inexperienced. On the other side of this, dealing with people more experienced than you, remember that basic respect goes a long way. I've met many people who are major contributors to critical projects, and they just put their shoes on 1 foot at a time, just like you and I. If everyone feels good when contributing to an open source project, it will continue. If you let sour emotions get the best of you and everyone in the project, it will consume the project along with it. So essentially, it's been a journey for me. I first got involved in the Ubuntu community at 13 years old. When I was 9 years old, my stepdad first showed me computers. He first showed me his method of working with Windows machines and just helping others with tech support. And that really did inspire me. It was a great journey to be able to look into that, and I got very interested in technology at that age. To my understanding at that point in time, there were 2 operating systems. There was Windows and Mac OS. And so I installed Windows because I didn't have a Mac. I didn't have the ability to install Mac OS on a computer. So I was working with Windows, and I found I would try and break things. I would edit the registry. I would try to tweak the panel in a way that I wanted it to work, and it just wouldn't do what I wanted it to do. At this point, I really decided there has to be a better way. There has to be something that I can use that is different than Windows or Mac OS. There's something that can give me this ability, this power to be able to customize my own machine. And I was doing some research, and I found this thing called Linux. Now, I was about 10 years old at the time, maybe 10 or 11, and I found this thing called Linux. And it was interesting to me. I had played Minecraft for a very long amount of time. In fact, I was good enough with Redstone where at about 11 years old, I built an entire 8-bit computer in Redstone, in Minecraft. And so I learned a lot about logic gates. I learned a lot about the different items that make up a computer, the way that computers do addition, subtraction, multiplication, and division. And through that process, I really found my passion for understanding the internals of a computer, for understanding the internals of software. And it drove me to go and look for a spot within the online community that I could actually go and contribute to. Essentially, I was looking around and I found this thing called Ubuntu. Now, for me, at the beginning, it was difficult to pronounce, and of course, I was kind of skeptical. This brings me to about 13 years old. I was at the point where I wanted to join this community. I'd read the packaging guide. I didn't make much sense of the packaging guide at the time, but I looked at those diagrams and I looked at what free software actually means, and it inspired me. I wanted to contribute to this community. The idea that anyone, whether they are somewhere in a corner of the world, compared to a large corporation, anyone can contribute to this thing if they have the skills. And that idea was incredibly inspiring for me. So at 13, I joined Ubuntu. I hopped in the IRC channels. I was using Kiwi IRC way back in the day when we had just a bunch of web-based IRC clients, and I just joined the Ubuntu IRC channel. Now, my first computer that I had on my own, I think my mom spent $100 for it on Facebook. And so it was a lower-end piece of hardware. And I found that with Ubuntu, I could install that on there, and I could still get all of my work done. I could still customize what I wanted to customize, the things that Windows didn't give me, and I was able to actually look at the code behind each of these components. And so I joined the IRC channel. The first interactions I've had were, does this thing have an age limit? Is this something that you need to be a certain age to be able to do? And the answer I got was no. So I found a mentor within that community. His name is Walter Lepczynski. And he took me, he trained me on some of the basics of, this is how you work with the Linux terminal. This is what you're looking for in certain configuration files. He really worked with me and got me to that point. And I'm eternally grateful for that. After contributing to Ubuntu for 3 months, now usually with Ubuntu membership, it is significant and sustained contributions for a period of 6 months, is what we usually say. I remember reading that it said 3 to 6 months, and I said, all right, I'm just going to give this a try. We're going to see if I can get it at 3 months. I'm just gonna see what happens. And I actually got Ubuntu membership after 3 months. Looking back on that, a couple of years later, when I did become a member of the membership board, they were skeptical. There was some dissent on that. They didn't want to, just give me the membership, but they also saw the passion and the drive that I had. And I'm thankful for them for giving me the chance to do that. So at 13, I became, of course, an Ubuntu member. No, I was 14 at the time. For some context, I know that earlier Jason said he was born in 2000. I was born 6 months to the day after 9/11. So that puts me March 2002. So this was about, so I was 14, what was that? 2015, 2016. One of the first Ubuntu dailies I installed, there was the option between Upstart and Systemd. So I've been really raised on Systemd as a component anyway. At about 14 or 15, I really wanted to do that development work. The reason I joined the community in the first place is because I read that packaging guide. I looked at those diagrams and I was inspired by the idea of free software. And so I wanted to learn what I could to be able to get into that development mindset. And the first thing that I ended up doing was bug triage. So I would go through and triage a lot of these bugs and really understand how a lot of this software worked. And some of the software worked really, really well within the Ubuntu community or within the Ubuntu archive. Some of it really didn't. And I, through those efforts, I really found out how a lot of it worked. And I transformed that into the knowledge that I have about packaging, et cetera. And it took a lot of work because the packaging guide really wasn't up to snuff, really. What's that? No worries. So at 14, I did attend my first Linux conference. I went to Linux Fest Northwest. I wanted to see what this community was about. I wanted to go and learn from these people in person. So, I applied for funds through the Community Donations Fund and was accepted. And really, what I found there at that Linux conference is that I felt at home. I felt like these people have the common interests that I have. And once I found that out, that really, really inspired me to continue with it a lot further. So at 15, I became an Ubuntu Master of the Universe. Now that title it really represents a lot of work. People say, oh, you're a Master of the Universe, etc., but it took countless hours of banging my head against the wall and failing over and over and over again until I finally had that success, until I finally got to the point where I knew a little bit about packaging. And it took a lot of people saying, well, you don't know what you're doing. Maybe you're a little bit too young for this. You don't have the skills necessary. And I looked past all of that. So yes, at 15, I became an Ubuntu Master of the Universe. And I also, around that time, Ubuntu, the community I originally joined within this space, they needed a release manager. Now, Walter was the release manager for Ubuntu, and it got to the point where we had some conflicts that I can't really publicly talk about, but we were in a situation where somebody needed to step up into that role. So I don't remember exactly how old I was. It was maybe 15 or 16. I became the Ubuntu release manager. Now, this was a burden. I really didn't know what I was getting myself into. The best way to describe it is drinking from the fire hose. There's a lot that comes in for a specific flavor that you need to be able to deal with. Okay, we're moving from Upstart to Systemd. That's a great example. You need to be able to adjust your flavor for that. The move from Pulse Audio to Pipewire, that's another move that we had to do even recently. There's a lot of these components where sometimes I feel like I was a little bit too young, but at the same time, I had that drive and I had that passion and I put the hours into it. So at 16, I also became a Debian developer. I became an Ubuntu Core developer and Debian developer, and for me, this was just a continuation of all of that work. I wanted to refine my skills because at the end of the day, I want to be able to tweak the software I have. It really comes down to, if I have, for example, the TV, or if I have, even the media display in my car, my main purpose, my main drive, my main passion is really to be able to understand that this is free software and that anyone can contribute to it, anyone can make it better. And so at 16, I really, I continued attending Linux conferences and I continued going along this path. It's been interesting. I've had a couple of different hats within that time. I was a member of the Ubuntu membership board. I was a member of the developer membership board. In fact, when I became a core developer for Ubuntu, essentially I was on the developer membership board. I had to abstain from my own thing. It's at that point I had to decide what I wanted to do, because if you're 16 and you're an Ubuntu Core developer and a Debian developer and a release manager, you really have to understand what is the next step here. What do I really want to do? And that is really give back to the community, give back to those people that are in a position that I once was in, and that's what I really find a lot of passion doing these days. It is looking at these people that are younger and coming up. For example, a great effort that's been done recently is the Ubuntu Unity project. That wouldn't really be possible without Rudra. And Rudra, I believe, Nathan, is he maybe 13 or 14 at this point? 14, yeah. I really like to give back to these types of communities. So through my time and through my experience, it's a bit of a, on the one hand, I feel like I have a lot of experience in these spaces and these efforts. On the other hand, I feel like, well, I sit in front of you today at 22 years old. There's part of me that does feel inexperienced, but I would like to share some of the aspects I've kept in mind just in those release management roles, just in keeping these communications with other people and building up my own skills and building up the community around me in doing that. One of the biggest things is, instead of assuming malice, assume ignorance. Now, it's a complicated concept, right? It's if you're interacting with somebody online, essentially, somebody could come off as abrasive. They could be saying, this is the truth, this is what I want to say, or it could be technically right even. For example, systemd has all these advantages. Well, if you say that to an upstart developer, you might get kind of mad. The main thing is have some compassion, have some empathy. Understand that everyone in here has a story. Everyone in here has gone through trials, tribulations to get to the spot where they are at today. And if we fail to remember that, if we fail to recognize that, if we treat each other with hostility instead of building each other up, it really puts a damper on things. And I'm happy to be a part of this community. So the other thing that I had, was just treat others with respect. And it's knowing that I may be a developer, I may be somebody who's really interested in code, but there's a lot of people that aren't interested in that. There are some people that want to do, for example, artwork or documentation or all of these items. And to become an Ubuntu member, there's no straightforward path for it. You don't have to be a developer. You don't have to do one of these things. In fact, if you hold a local community team, if you start one of those and maintain one of those, that is definitely an avenue for Ubuntu membership. There's a great deal of things you can do within the Ubuntu community and within the wider free software community. All it takes is understanding that you will fail. There are times where you want to do everything you can to make something work and it just doesn't work out. At that point, you can make a decision. You can either decide to give up, say, this isn't for me, I'm going to move on and do something else. Or you can simply just say, this is something that I'd like to continue to pursue. Despite all of these shortcomings, I'd like to continue and really make an impact. And there have been a great deal of times where I've said something or done something that, of course, being in the community at 14, 15, 16 years old, I'll look back at some of these communications. I'll look back at the mailing list posts. I'll look back at the IRC logs. And it frustrates me to see that sometimes. And I think that in the age of technology, in the age of information, everybody has, if you're on social media or not, there's some history behind that. And if you look at somebody's Twitter posts, for example, from 8 years ago, you're really missing a lot of context. You're really missing who that person is today versus who they were back then. And I think if we focus on just, bringing up these old elements, you're really assuming malice and not just ignorance. There are some people who don't have that fear of coming up and speaking. There are people who don't have that fear of continuing and doing things that make them uncomfortable. And really, that's how you grow. It's putting yourself in that spot of, okay, I may not know everything about this. I may not know everything about this particular aspect. I may not know everything about, for example, snaps or something along those lines. But you just dig into it and you're persistent. And that's really the key to success. I've had people ask me over the years, how do you do it? How do you manage this? How do you do it? And there's no straightforward answer besides that. I'd like there to be some pathway, some idea of this is how you start in a specific part of Ubuntu and end up becoming an Ubuntu member and actually making a difference in this community, because it shouldn't take the amount of persistence that I had to have. It shouldn't take banging your head against the wall over and over and over to get to that point where you're making a meaningful impact. I think there is actual value in a meritocracy. Now, of course, duocracy is a little bit different. If you look at a talk by Merlin, a member of the Community Council, he does go through the elements of duocracy versus meritocracy. I'm a very firm believer. I was raised on the idea that everybody, regardless of where you're from, regardless of what you look like, your gender, etc., you have a chance to make an impact in this community. And some people weren't raised on that. Some people weren't. Some people don't have those ideas, and it's frustrating to see sometimes. I think that's what I have for my talk here. Are there any questions?
Actually, I have more to get them to, because your talk right now is something similar to one that I've had boiling in my head for years.
Could you please repeat it into the microphone? I apologize.
So your talk is something similar to one that I have been boiling in my head for years.
Yes.
So you mentioned the membership thing with Ubuntu.
Mm-hmm.
When I was trying to apply for membership with the OpenSUSE community, going back to the previous question I had with the previous talk about communities and the separate alcoves and the lack of bridges, one of those was, when I applied, if you weren't active on the mailing list, they wouldn't even bother glancing at you for membership with the OpenSUSE community. So it's really interesting to hear how things have not only changed with OpenSUSE, but also how things worked with the Ubuntu community. So thank you so very much.
Of course. There's a common misconception too. People say, "Oh, Launchpad karma. If you have all this Launchpad karma, you're definitely an Ubuntu member, right?" Yeah, that's not the case. If you're not active on the mailing list, well, here's the thing. In 2024, we're really going through a big transition point. As they mentioned, we're looking to move a lot towards matrix. We're looking to move a lot towards discourse, etc. And it's not because the mailing lists are bad. It's not because IRC is bad. I love IRC. IRC is my IRC client, and if I could use that for forever, I would. I would love to have a matrix client or matrix plugin for it. And before you say it, I know WeChat exists. I still use IRC. So we should work to really bridge these gaps between the old classic style of mailing lists and what we have today. And it really comes down to bridging the gap between, communities or people that are younger and actually grew up with technology, who want something like Matrix, who want something like Discourse, and the people who have been there for forever and have the routine and the existing infrastructure around that. I think that's something we're working on. I call it reducing friction within the community. Other people call it defragmenting the Ubuntu community. I think that in general, if we reduce friction for people to come into the community, it benefits not only the community itself, but it benefits the people who are drinking from the fire hose, quite literally. There's a lot that you have to deal with that is incoming, and to be able to delegate some of that off is just so amazing. And this is something that I'm going to be talking about in my Ubuntu talk tomorrow. Essentially, we're at the point with Ubuntu, and I never thought I would be able to say this, where we have the largest team out of all 10 flavors.
Subtle flex.
I've seriously tried to look and see, is there a bigger team? Is there a comparable team? And I can't find one. And it's not to say that it's me, because I'm not Ubuntu. The 10 people on the Ubuntu team, they as a whole comprise Ubuntu. We have someone working on documentation. We have people working on different development tasks. We have QA people, and everyone plays a part in that. If somebody wants to come into the Ubuntu community, I'm more than happy to help usher them in. Any further questions? Or do we not have much time left? Oh, okay.
I can get around, people. So I have real quick an additional thing to pass to membership. You can just do community outreach like I have did, and being autistic, that's not easy for me, so just find something that works for you.
Thank you. I'll add one thing to that, too. Let's jump up here for the live stream. I did make the point in Riga that I'm at the Ubuntu Community Council, which is the largest governing body on the community side in Ubuntu. I've done this and that. And so anyway, the reason I'm here, the reason I have that whole Ubuntu journey, the reason I do this every year and run the booth and get to spend time with all of you is because 16 years ago, somebody asked me, SCaLE reached out and said, hey, there's an Ubuntu California team, you're nearby, you do events, right? You want to run a booth? We said yes. The reason I'm here, the reason people recognize me, which is still weird to me, is because somebody asked me to run a booth because I lived nearby. And we tried, it wasn't just me, Neil Bussett, Greg Simonian, Joe Yasumoto, or Joe Smith later, Yasumoto on IRC. And someone asked us to run a booth because we lived nearby. And we did. And nobody told us to stop. So
yeah,
if you want to, if you're interested in doing these things, right, giving a talk, we have an open process every year for these talks. If you were what's it like to run a booth? Stop by the booth and hang around for 20 minutes and talk to people who come up. We welcome that from the community. And a lot of people have gotten their start, as well as, is this your first talk?
I think the last talk I gave was 5 years ago.
Yeah. So, he said, well, let's go for it. And I've been a public speaker for about 16, 17 years now, thanks to this, right? I know exactly when you relax because we have such a wonderful, friendly audience here. I always tell people SCaLE is the best place, the friendliest audience to try these things out, see if you're cut for it. And I know exactly when you stop reading your notes and just start talking. So, which is when all that work of writing notes pays off. That was a fantastic talk.
Thanks.
So thank you. If we have a question, perfect. Could we have a little more time? Oh, a comment.
Simon, thank you for doing the Ubuntu Weekly.
Oh, the Ubuntu Weekly newsletter?
Yes, very good.
Yes. So it's funny. I haven't actually gone up to. Yes, we haven't met yet, but that's Liz. She ran the Ubuntu Weekly newsletter for a good amount of time, and there were a couple of. How long did I run it for? A couple months? A few months. Yes. I will never forget the time where Liz asked for my address, and I'm like, well, why do you need my address? I want to send you stickers. And a couple of weeks later, I got these stickers in the mail, and I still have them. So it's those little things really that help keep people in the community. I did run the Ubuntu Weekly newsletter for a few months, and it taught me a lot about writing, and it taught me that I love to write. And then, of course, as a developer, it's something that it's not really number one on my resume, but at the same time, it is a very meaningful experience, and it's something that we do always need more people helping with the Ubuntu Weekly newsletter. So if anyone is interested, if you have some writing ability or editorial ability, anyone is welcome. You can, of course, join I believe it's the Ubuntu News IRC channel. Otherwise, there are discourse posts. So if you go to discourse.ubuntu.com, search for the Ubuntu Weekly newsletter, and it's every week, yes. The other thing, too, that I'll mention, just so that I make this clear, is Ubuntu is what it is really because of who we all are in the Ubuntu community. There are people here who have contrasting opinions compared to some opinions that I have, and it's not for me to really say a lot of those publicly, but what I will say is that despite having contrasting opinions on technical items, political items, we have a rule in Ubuntu, we don't bring politics into it at all, because it just devolves. It really just does devolve. We have different opinions, all of us do, and yet we still find a way to work together. And that's really what's powerful about the Ubuntu community and the free software community. Does anyone have any further questions or comments?
I don't know if Jason counts. Do you count?
What's that?
Sorry, Nathan. I feel the need to make you exercise today, but what is it?
Get your steps in.
Yes, get your steps in. So I definitely really like this talk because, I often find that a lot of people, at least, even when I was in university, when I was like, oh, I'm going to work, at Canonical and, develop open source software, and they were like, oh, well, how do you get involved with that? And, and as my response to that was kind of like, it just happens, Sometimes you just fix a bug, and next thing you know, you're a core maintainer. But, one thing that I really want to ask is, like, if you were to take, like, say, like, little Simon today, like little 13-year-old Simon who is, 8 months younger than me, and, tell him, like, hey, here's an opportunity for you to get involved and make meaningful contributions to Ubuntu, what would you say? Because, at least I know when I first started, it was extremely daunting because it's like, Ubuntu is a very well-established community, it has a long history, it's used on like 40 million devices, potentially even more. So it's like, how do you kind of be able to be that bridge in for like a new contributor who wants to do something?
The biggest thing I would say is join the community. We have Matrix channels, etc. We have IRC channels. If you're an IRC fan, we have a discourse instance. The first thing that you would do really to make that impact is to join one of those and really just get involved. Sort of take the pulse of the community, see where it's at, and find something that makes you passionate. So this is something that I do within the Ubuntu team. When somebody joins our channels, when somebody joins our spaces, wherever it ends up being, I ask them a simple question: what do you like to do? And to them, it's, well, what do you mean? Do you like to do development? Do you like to do bug triage? And if they give me an undecisive answer, I'll give them a little taste of everything to help them discover what they like to do. And that's something that, part of me wishes that I could be that person for that 13-year-old Simon that welcomes people into that community. And that's really what I'd say is join the community, get involved, get a pulse on things, and then just start by experimenting, playing around. And I've said it maybe 3 or 4 times now, but I'll say it again. A lot of this involves failing over and over and over again. It's that persistence of, I'm not going to give up. I'm not going to let it get the best of me, and I'm going to just continue doing what I think is right. And of course, there are limits to that. But if you're looking at free software and wanting to contribute, that's the most impactful thing I could say you could do.
All right, sweet, thank you. Get those steps.
Just a little thing I'd like to add. Ken Van Dyne, involved with Ubuntu Desktop for many years now.
Go ahead.
Is if you have an idea of something you would like to do within the community, it doesn't have to be code, it could be documentation, it could be translations, any sort of thing. I would urge you, take the leap. Don't feel like, oh, I don't really know how to do this yet, or I'm nobody because I'm not involved yet. You never become involved unless you take that leap. So take that step. It's the most welcoming community I have ever seen in my life. You will not be disappointed if you do it. Find a way to engage, join a Matrix channel. If you don't have an idea but you want to be part of something, jump in and say hi. And just listen, lurk to see what people are talking about and find ways to engage. But I would encourage you, don't be afraid. Just do it. That's the best way to get started, is just do it. Nobody's going to tell you not to.
And I would even add on to that point as well. Everyone from myself to Nathan Haynes to Ken Van Dyne to Jason, everyone started really at that point of, I want to join this thing, and I just need a place to start. Everyone had a start in the community, and the only thing really preventing you from becoming that, these people that you look up to is you need to have that confidence to take that first step, and it's difficult. It really is difficult sometimes.
Just like nobody told Nathan to stop running the booth.
Just, yeah,
There
as
you
Ken
go.
said, just like no one told me to stop running the booth, and you've been stuck with me ever since.
Yeah, you asked me 12 years ago. I think it's been now.
About that, and it's been fantastic. It's made my life a lot easier. Any additional questions? So after this is
Jason has one.
still not sure he counts.
Sorry about that. Yeah, so I guess one last question that I have for you, Simon, is kind of going back to the original title, or the title of your talk. Open source is not just code, and I think that's really a great mindset to have, because a lot of time you might hop on GitHub, look at some random project that's recommended, and you see all this stuff going on, all these massive technical contributions, and you're just kind of like, oh, I don't even know what to do. It's basically me whenever I look at one of a very mature Rust project. I'm a Python programmer by training, but do a little Go on the side. And so I guess one thing that I really have for you, and kind of circling around new contributors and taking that leap, how do you think we can kind of as a community, as maybe say an established member like yourself, how do you think we can go out to these individuals and encourage them to join? How can we kind of be that bridge, be that support that makes them feel comfortable to take that leap, so that when they do try and fail, they're not discouraged and give up?
I'll do 2 mics. No. I think I'll tell you how I do this, and I'm not sure that I have a wider answer, but hopefully this answer will inspire some feedback, perhaps. I've learned to identify when somebody is a newer contributor, when they have that interest, when they want to jump into something. It's pretty easy to identify, and it's up to the existing people within that community to really say, okay, I'd like to help you. And that's a really big thing that you have. Now, as the release manager of Ubuntu, I take on the tasks that, for the other 9 people, they don't really want to take them on. One of those things is I put a very high value on if somebody new comes in, give them the time of day, really. It may seem silly, like, okay, if you have 500 people joining your channels all wanting to contribute, well, that's actually a good problem to have, not a bad one. You should have people within your team that are focused on that are focused on that community management aspect. And I look up to the community council, and I look up to the work that the canonical community team does as well, simply because they're driving a lot of that effort. And I think for anyone running their own community or anyone that even wants to get involved in Ubuntu, it's finding that person that will help you take that next step. For me, that was Walter. Now, Walter's a busy guy. He can't be that guy for everyone. But it's finding that person who can really mentor you and providing that mentorship from the project side. That's what I would say. Yep.
Okay, so we have a little break, and coming up at noon, we have Ken Van Dyne, and his talk you will not want to miss. So stretch your legs, water if you need it, but make sure to come back here by noon. It's going to be amazing. And thank you, Simon.
Thank you. And also, before you head out, if you'd like to grab any merch here, if you're going out for break or planning on coming back later, we do have some Ubuntu stuff up here, so feel free to stop by and pick some up.
Welcome back from the break. It's time for our next talk. Ken Van Dyne is a rock star, and because I'm impatient, I will just say that the name of this talk is Ubuntu Core Desktop, Immutable, Secure, Reliable, and let him get to it. Ken?
Hello, everybody. Hope you're enjoying your time at SCaLE so far, and definitely UbuCon. I know I am. It's been a long time since I've been here. I think my last SCaLE was 2007, so before UbuCon started. So I'm excited to be here. So I want to talk a little bit about Ubuntu Core Desktop. I'll apologize for anybody who's been to the Ubuntu Summit or watched the live stream. Part of this is a repeat of what I did at the Ubuntu Summit in Riga, but I have actually added a bunch of content. So a few of the slides I'll kind of skim past a little bit because you can watch that on the internet at your leisure, and this audience probably knows a fair bit about Ubuntu already. So who uses Ubuntu? You can probably guess, hopefully most of you use Ubuntu, but gamers use Ubuntu, scientists, makers, artists, educators, IT professionals. There's a wide array of types of people who use Ubuntu, which is fantastic. Where do they use it? Ubuntu Desktop is used all over the place. It's in manufacturing, in government offices. You can find it in pretty much any sort of environment. Of course, Ubuntu, our users tend to value certain things like privacy and performance, security. People are more aware of these sorts of things, our typical users. Choice, of course. These are some of the things we feel our users really value. And of course, this is what we're here to really talk about is Ubuntu Core Desktop. So, but before we really dive into what Core Desktop really is, let's talk a little bit about what Ubuntu Core is. I'm sure many of you have heard of Ubuntu Core. It's usually thought of as something that's used for IoT devices and embedded environments and things like that. And yes, until now, that's primarily the types of places where Ubuntu Core has been used. It's fully containerized Ubuntu, optimized for size, performance, and security. Basically, if you need something that runs in a small space, going to be robust, reliable, guaranteed to be up all the time, it's not going to break when it updates in the field, those sorts of things, you really want to be running Ubuntu Core. Some of the primary benefits of Ubuntu Core is, of course, security and maintenance. The software stack has got the longest support window out there. Fully containerized, separation between your applications and your kernel and everything. They're all installed. Essentially, they're all in their own little container. Every app that gets installed is in its own container. Over-the-air updates utilize deltas and rollbacks, so it only downloads the bits that change, not the entire package every time it has to download. Rollbacks, if an update fails, it rolls back to the previous known good. And it works in air-cap environments as well. And of course, the same kernel and libraries for your production and your development environment. So you can be sure your application is going to work in the production environment. And we can't talk about Ubuntu Core without really talking about snaps, right? I'm sure everybody's heard of snaps. Some controversy sometimes, everybody loves that. But the primary gist of what a snap is a fully confined package that contains everything it needs to run, okay? So regardless of what environment you're running the snap in, like say Firefox, let's use that as an example. Firefox in Ubuntu is a snap. If you test that Firefox version on, say, an Ubuntu 2204 device, you are sure to get the same experience out of that version of Firefox, that exact revision out of the Snap Store on, say, an Ubuntu 1804 device. You don't need to test your applications on all the various host operating system versions that you may need that to run on. You know that it's going to run because Snapd provides that level of support. Provides a lot of security built in, like access to system resources, your camera. It doesn't just have unfeathered access to all of these things, your microphone. You can turn those things off if you want. you can prevent it having access to that. You know this application that you just installed on the internet can't go scavenge things out of your address book, find all your contacts and email them all. They don't have access to that information. You have to explicitly tell it that you will allow access when it needs it. And of course, you know, the package maintainers or the upstream software vendors, things like that, you know, they can keep very close eyes on when the snap needs to be published again to ensure you're getting all the CVE fixes, because maybe your app depends on OpenSSL, and there's a exploit in OpenSSL. The snap publisher can just rebuild their snap and automatically push out updates to the users, and the version of SSL that's bundled in your snap is now patched. You don't have to worry about that sort of thing. And of course, with the over-the-air updates, the snap versions can move forward and backwards reliably. So if you update to a new version and for some reason it doesn't do something that you need it to do, you can roll back to the previous version. You can install older versions and ensure that everything that is needed for that version to run still works. That's not always the case in classic Ubuntu, where if you go download this deb of an older version of this application, maybe a dependency that it needed has changed. And those things aren't all self-contained. So you're subject to some instability there, or maybe it won't behave the way you would like. Some of these snaps, you can actually control what channels things come from. So you could have like, use LXD as an example. LXD publishes their versions in what we call tracks. So if you want to track, say, the 4.0 version of it, even though latest stables in the 5.0 series, you can just pin your device to only track updates from the 4.0 track. And as new fixes for that stable release series goes out, you automatically get updates for that version, and you'll stay on 4.0. You have that level of control, and you can pick and choose. Error handling and automatic recovery. Snaps it has this built-in mechanism for health checks. So as the publisher of the snap, you can write some various scripts and things that get bundled in your snap that says if these things don't return true, it's considered a failure. So if it fails a health check, that snap update will automatically roll back to the previous revision. So as a user, your system is still working. So you can ensure that everything is the way you expect it to be. And of course, Delta updates, it only downloads the bits necessary, not the entire package, which is also great, especially in like environments where you may have like a 4G modem built into an IoT device. That sort of thing is very important. So now onto Ubuntu Core Desktop. This is our solution for a fully immutable, secure, and modular desktop operating system. So the idea here is we want to build on that same rock-solid Ubuntu Core experience that we've spent the last decade creating, and we want to leverage that now in a desktop space where you may have the need for a really reliable, secure, robust environment, like say in your enterprise with 10,000 machines and maybe a call center or something, where these machines have to be up and they have to always be working. In a very managed environment, this is ideal. And as I mentioned, we've been working on Ubuntu Core now for over 10 years, primarily targeting the IoT space. We feel this is a great opportunity now to start building a desktop experience on top of that. Initially, we're looking at like thin clients and enterprise type users really being very interested in this sort of thing, and probably some student users as well. You can very much think of this as like a Chromebook type experience. It's not quite as limiting as a Chromebook. You can actually install pretty much any Ubuntu software on it as long as it's available as a snap, but they run as native applications. It's not just web type applications. But if you need an environment that's really reliable and secure, you'll get that. So I talked a little bit about kind of what we're targeting now, but this is the progression of what the spectrum of devices that Ubuntu Core is targeted. So we've kind of conquered the IoT space. We've been in kiosks for quite a while now, things like digital signage, those fancy digital ordering boards like in fast food restaurants and things like that. Those types of things are sometimes running Ubuntu Core. Single purpose type devices, which is very much similar to the kiosk type experience. But it doesn't have to be just like a browser. It could be a device that just needs to be able to run this one application for managing a 3D printer or something, right? Or in manufacturing type environments where it needs to be the management node that manages this thing in a plant floor. Those sorts of things are very commonly found with Ubuntu Core. So now kind of the next step is going after, like, say, thin clients, broad enterprise type deployments, which I'll talk a bit about in kind of the second half of this talk, is kind of where we see this going. We're not quite ready yet for the daily use, although I will say I'm using it daily. I am actually presenting this from Ubuntu Core. So I do use this for most of my everyday needs. I will say I use a ThinkPad for a fair bit of my development work that I do. But when I'm on video calls all day and things like that with colleagues and customers and partners and things, I'm usually on my Ubuntu Core Desktop machine. And after we get to the point where we feel like it's really ready for daily use, then we'll start tweaking the experience to make it more developer friendly. We already support things like container workflows, so you can actually install LXD on it, create containers, and inside of a container you can do anything you want. You could create a Fedora container and do some RPM packaging if you want. That totally works. So if you need to do those sorts of things, we're still going to polish that experience up a little bit to be a little bit better integrated with some, like, popular IDEs and things like that for this container-based development workflow. But we're working towards that. So a little bit about how it's built. So this is going to be a fair bit different than classic Ubuntu, is what we're calling it these days. But since this is built on top of Core, the concept behind Core is a little bit different. So everything is a snap. We have the kernel snap at the bottom. We have this thing called a gadget snap, which I'll talk a little bit more about later, but this is effectively providing some metadata about how the operating system image is going to look. Snapd itself is a snap, and this is what manages all the snaps on the system and the resources and things like that. Then we have something called a boot base, and what this boot base is effectively a minimal root file system that the operating system needs. And this minimal root file system is the thing that every snap has access to on the system. Read-only, of course, but it can execute commands that are expected to be found in a root file system, those sorts of things. And this is one of the very interesting parts, is we actually have the Ubuntu Desktop session as a snap. So we're running the entire GNOME desktop environment inside of a fully confined snap, where it does not have unfeathered access to everything on your device. You could actually block access to, say, the camera. So GNOME couldn't access your camera if you wanted to. I don't know why you would actually want to, but you could do that. But it is running inside of its own container. An application not behaving well will not affect your desktop experience. And then this concept of additional bases. So when a snap is built, it has to declare what base it's designed to work with. And our bases we call them core snaps. So right now, Core 22 is based on Ubuntu 22.04. We will soon have a Core 24 based on 24.04. But say you have a snap in the store that the publisher, they're publishing new versions of their software, but they don't want to rebase it because maybe they depend on an old glibc from 1804 or something. They could define Core 18 as their base. So that's fine, even though your system is running, say, 24.04, that application is going to behave the same way that software developer wanted it to behave, because it will have access to that version of glibc in Core 18, because when that snap gets installed on the system, it will install Core 18 as well. So we have the additional bases there, so we can provide enough necessary components to run that software. And it doesn't affect rest of your system. So you can have 2 glibcs there and it's fine. And then, of course, applications. So, any sort of snap that you want to install, you can install on it. Firefox, Chromium, Steam, if you want to do some gaming, those sorts of things. And a little bit about some of these. So, like, for example, some use cases it's really nice having the kernel as a snap. Imagine a day where we may have, say, a gaming optimized kernel that has some things tweaked, might not be as reliable for like a large-scale enterprise type deployment, but it's definitely something you want for your particular workflow. Or maybe you need a real-time kernel for some reason, or those sorts of things. FIPS compliant, something like that. You could actually switch channels for which version of the kernel you want to track reliably without worrying about having an environment that doesn't work on your system. You can just replace the kernel and you're good to go. And back to what I mentioned there with the desktop session. Yeah, I guess I went into more detail on this slide. But it's the same sort of thing. The idea is a flavor could, like Ubuntu, could have their own desktop session snap that provides their experience on top of all these other components. So as a flavor, you don't need to replace all these other components. You just drop in a snap that provides your desktop session. There could be a KDE one, Mate, those sorts of things, or maybe you want a variation of the Ubuntu desktop session that is GNOME with most of the Ubuntu experience, but maybe you don't want the Ubuntu dock. You could create your own snap that inherits all of our stuff and just overrides a few extensions that get loaded, that sort of thing. And just drop that into the system and you're good to go. Oh, and imagine a day where perhaps in our development series, like right now we're working on 2404, if we had a devel track of that Ubuntu desktop session where you have your entire operating system is super stable, the kernel is reliable, it's going to support your hardware, all those sorts of things, but you just want that latest version of GNOME. And maybe, we're not doing it yet, but maybe we're building daily builds of GNOME into an edge channel of a devel track. You could switch your desktop session to use devel edge and live on that bleeding edge and get the newest version of GNOME, whether it's stable or not, without tainting the rest of your system, without relying on an unreliable kernel, those sorts of things. That's totally possible. I'm hoping someday we will do something like that, and then we'll effectively have a rolling release.
If you're going to get to this later,
Okay.
feel free to tell me. But how swappable is the kernel snap scenario that you mentioned? Is it something like if you forget to leave your gaming kernel enabled and then something else breaks and just won't run? Or is this something you have to build your system in order on?
The kernel snap, it should just be replaceable. So you can do, yeah, so he was asking how reliable it is, like if you forget to switch your kernel, right? What happens? Well, I mean, it's possible that your kernel doesn't actually support your hardware, but you would know that right away, and actually you could do a snap rollback or snap revert, and that revert will revert back to the previous known good one. So when you switch to that kernel, if it doesn't support all your hardware, you will know very quickly. And in most cases, it would probably fail actually to switch and automatically roll back. But as a user, if you notice a snap that you just updated, or maybe you changed tracks, like in the kernel case, if you notice it's not doing what you want, there's a revert command that will revert that last change back to the known good. So you can very easily get back, even if your system's unstable, you can very easily get back. You could, and it does keep multiple versions around, so you could easily have multiple kernels installed and very rapidly switch between them and just do a reboot if you want. So if you wanted to keep the kernel one, the gaming one around and your everyday one around, you could actually make that change with a quick reboot as well.
If we've got a kernel that isn't booting at all, let's say I was a very naughty boy and I installed an ARM-HF kernel on my AM64 machine. So how do you roll back in that?
There's a thing built into Grub on Ubuntu Core for dealing with that sort of scenario. I've never actually dealt with it, but there is an option if you bring up the Grub menu in Ubuntu Core to do something like that. All right. So what makes this so exciting? So we all love Linux and open source and Ubuntu, of course. And sometimes it doesn't always do exactly what we want. Sometimes we install somebody's software and it doesn't behave well. And often we enjoy the tinkering part of it and making it work. But there's oftentimes environments where that's not desirable, right? Stability is key. You just need to use this computer to get work done. So that's what makes this very exciting. Is this can be, classic Ubuntu is not going away, right? This is an additional offering that will provide this level of reliability that's necessary for Ubuntu in many environments. So things like, system files just can't be randomly altered. Like you can't open up a terminal and sudo rm some important piece of that root file system, because in fact, that root file system is read-only. And it's actually, that file that you want to delete is not actually a single file. It is actually contained inside of a squashfs file that happens to be mounted in that location. So you can't taint those kinds of things accidentally. Atomic updates that we talked about a little bit there, the fact that an update could potentially break something. The health checks and that automatic rollback is huge. And of course, running each application in its own confined environment, you can trust that Spotify is going to work the way Spotify is supposed to work, because it's been tested. We know it's going to work. You can install it on Ubuntu Core Desktop. Even though we've only tested it on classic Ubuntu, you'll know that snap's going to work. We support things, and now classic Ubuntu is getting this as well, which is exciting. But like, for example, TPM-backed full disk encryption, secure boot, things like that, all stuff that Ubuntu Core has actually supported for many years now. Our TPM-backed full disk encryption story in classic Ubuntu is actually built all off of the Ubuntu Core full disk encryption story, which has been around for several years now. It's well proven already. You can customize various elements, like I talked about a little bit, having maybe a different desktop session, things like that. You could easily decide, I want to switch to KDE today. You could easily make that switch. You could install that other snap, and you could have a KT environment and a GNOME environment installed without worrying about all those dependencies, because that KDE environment will have all of its own dependencies built in, and it will not conflict with the versions of glib or whatever that you need in that GNOME environment. And of course, you can, in creating these desktop sessions, you could actually have something that's very locked down or trimmed down. Maybe you disable access to many things. Maybe you don't need the full dock and app spread in GNOME. You just need the ability for that user on this thin client workstation to be able to launch 2 apps. You could drop in a desktop session that only allows access to those 2 apps in a very controlled type environment. Manageability, one thing that's very key for this type of deployment, like in a large enterprise, is knowing that your systems are all identical, right? Like you need to know what systems are potentially exposed to what potential exploit, those sorts of things. You need reporting, those kinds of things. So in this case, you can trust that all of these systems are exactly the same. There isn't some random file that somebody's downloaded off the internet. They have sudo access on their system. They drop in a replacement to user bin ls. That can't happen in this sort of environment, right? And of course, automatic and atomic updates. The systems generally automatically update. You can't actually turn off that automatic refresh these days. But oftentimes you do want that automatic update. But in an enterprise type environment, you can actually gate when those updates go out to devices. But the devices can automatically update every 4 hours. And in that enterprise, you say, okay, I want to turn on this update for this package now. Those devices in the next few hours will all get them. Snapped applications are only have access to things that they're permitted to, so you can really control those kinds of things. And in an enterprise type environment, you could actually control, like, if you wanted to disable everybody's camera, you could remotely disable all the cameras on all those Ubuntu Core devices inside of your enterprise if you want. So I've mentioned enterprise a fair bit already. I'm going to dive in a little bit more detail on how we would envision an enterprise really rolling out something based on Core Desktop in a large-scale environment. So, back to this diagram here that shows all the various components. the piece, it was on the other slides, but I didn't talk about it yet, the model assertion. This is effectively a map of all the components that go into building that operating system image, okay? It's really just a JSON file. I'll show you an example of that here in a bit, but it's got some metadata about how you want to kind of construct this thing, and this is where you define the various snaps that need to be included. So here's a little snippet of that JSON that I talked about. I'm not going to really talk about most of the details there, but there's a few interesting things here. One is the grade is listed as signed. You could also do dangerous, which means not everything is necessarily has to be cryptographically signed in order to run. But in this case, if you use signed, you do have to have a signed model assertion for the system to even boot. You can specify the storage safety here. You notice in my example, I specified prefer encrypted. So in this sort of environment, when this gets installed on a machine, if a TPM is available to it, it will automatically use that TPM and automatically use full disk encryption. You can also require it as well, so it'll only install itself on machines that it can use the TPM for, or you can disable encryption completely if you would like. And you specify what that base is here. In this case, it's Core 22 Desktop. And there's a stanza there, which I have ... in. This is where you list all the various snaps that go into it. And yes?
Sorry, just real quick, would you specify like how many versions of the snaps by default?
I will cover that in a minute. Yeah, I'll cover that. Yeah. So here's a little excerpt. This isn't a complete list of what I have in mine here, but this is how you define in that JSON file which snaps to include. So in this case, I'm going to get into the gadget here in a few minutes, but that first one is a gadget snap that may be named Ubuntu PC Desktop. Type is gadget, and this has some metadata about how things are built. Which kernel to use. So in this case, I'm choosing the kernel from the 2310 stable channel. Which desktop snap, Ubuntu Desktop Session from latest stable. Which version of Firefox to include. And you could add any number of snaps that you may want to have there. But you define all of these in the JSON file. And then you sign that JSON file using a snap utility for signing it, which creates a signed YAML file, which can be trusted. Now we'll talk a little bit about the gadget. So this is some Ubuntu Core terminology that I think a lot of people aren't familiar with. But effectively, what the gadget does is defines various information about what the operating system image needs to look like. So for example, the storage layout, what the file systems may be necessary. Maybe you need to create 3 or 4 file systems for some particular workload or something like that. You can define that in the gadget. You can also define things like, and I think the next slide actually covers it. This is a little snippet of what it looks like. It's a YAML format. But if you see the section there where it says defaults, this is where you set various settings that need to be honored throughout your device. So we have a couple experimental things enabled here because some of these things are still experimental in Core Desktop. But you see the refresh retain value there of 2. That tells the system to keep 2 copies of every snap installed. You can set that to 3, 4, 5, and it'll keep that many, it uses more disk space. But if it keeps multiples around, you can very quickly and easily switch between them without having to download new revisions and stuff like that. Oftentimes, it's just a quick restart of the application or a reboot in the case of a couple special snaps. I'm going to talk a little bit more about Landscape in a few minutes, but Landscape is a fleet management solution that can manage large-scale deployments of these machines. This is an example of an Ubuntu Core device being able to auto-enroll in Landscape. So you can imagine a fleet of 10,000 machines inside of an enterprise. They all get booted up for the first time. When they get booted up, instead of having to go and physically sit at the machine and put in things like the URL to how to find the landscape server, or a registration key to allow it to register with that, those sorts of things. You know, you would traditionally have to do that sort of thing manually. With this Ubuntu Core type solution, the machines will actually auto-enroll in that landscape instance. So they will just start, as they boot up, they'll start being populated in landscape so you can manage those machines remotely. So those are really just settings on the snap that's provided. So in this case, landscape client is a snap, which provides an agent on the device to allow it to manage it. And then these are snap settings that get set by the snap automatically when it gets installed on the system. And then we have, it's a relatively new tool called Ubuntu Image. This is our kind of next generation way of building Ubuntu images. I'm looking forward to the day where we can use this to build our classic ISOs, because I'm sure, Simon, you're well aware of how much fun that is. Ubuntu Image is much more modern. It takes a declarative type input and outputs a bootable operating system image. So in this case, it takes as input that signed model assertion that I talked about, and it outputs an operating system image that can be booted up on the system. Maybe it auto-installs itself, or maybe it provides you a guided install, any number of ways that it can actually be installed on the system, but it will create that image. Ubuntu Image has been used now for a long time for building Ubuntu Core images. It supports it well for Core Desktop. We're not quite there yet to use Ubuntu Image for Classic, but we are getting close. I'm looking forward to that. But that's how we actually produce an asset that can be used in the field to actually install it on somebody's system. Now, this is where I mentioned landscape a few minutes ago. Landscape is just for large-scale systems management, right? If you have a fleet of machines and you need to be able to create reports on them, you know, you need to know what your exposure is to some particular bug. Like, you know, Firefox version X or whatever has some sort of a CVE against it. You need to know which devices in your organization has that version of Firefox. You have a lot of control over that automatically by being based on Ubuntu Core and the snaps and things automatically updating, things like that. But in landscape, you can actually create reports. You can actually get some visibility on exactly what's installed on your systems, and you can actually control that too. Maybe you can say, I want to update these 100 machines to this new version of something and see how it goes first. You could actually control that sort of thing. Pushing out, roll out security fixes, things like that. This landscape has been used for a long time already on classic Ubuntu, so all of these things were available with existing classic Ubuntu. It's recently gained support for Ubuntu Core. But we see, in an enterprise type scenario with Core Desktop, landscape being a critical component there. And you can automate any sort of thing. You can create automated monitoring graphs, all kinds of things for the devices in the field. So you can manage software on the devices, services that may be running. So maybe you need to find out if the devices in your enterprise have this particular service running or not, because at the time that you built it, you weren't really thinking about it. But now once you realize this could potentially be an issue, you could scan the devices in your enterprise and find which devices may be running that service. And you can remotely disable it if you need to, or enable it even. You can remotely manage the user accounts on the system. So like if you need to create an account for some new software or something that's going to be installed on the system, or maybe provisioning a machine that's now being reused for this new person, you could create a new local account. Or you could even manage things like Active Directory type integration, like allowing access to enroll in a domain, things like that. Of course, viewing the device state, what state the machines are in, which ones are up now, what are their current uptime, resource utilizations, are the machines running low on memory? You can see all those sorts of things. And of course, access to logs, being able to capture logs to debug problems on a particular machine. Maybe a user is having trouble and they've called the help desk and submitted a ticket. You can remotely pull system logs from it via landscape. That's it. Questions? I'm sure there's plenty. Simon.
I have one question for you. So all of these are really great ideas. I love them. And the one piece of constructive criticism I keep hearing, or criticism regardless, whether it's constructive or not, over and over is the Snap Store is proprietary, and so is Landscape. What do you do to speak to those people who have those concerns? What would you say to them?
Well, yes. So the Snap Store, the back end to the store itself, yes, it is proprietary. Everything that runs on the systems that actually get deployed in the field is all open source. I can't speak to whether or not any of that may change in the future. But yes, the back end is proprietary. That question's been asked on Reddit like a million times. I am not necessarily qualified to answer that, but I will assure you everything that actually gets deployed on anybody's device is 100% open source. We well documented the API to the store. It would be easy easy. It could be completely replicated if somebody wanted to create a store that functioned the exact same way. And we actually did see that happen, and I'm very glad that it did on the Click Store, which was the predecessor to the Snap Store. There's an open store that got taken over by UBports that basically was developed to that spec that we had for our store. And that is still running today for the UBports project. So it's been done before. Somebody has created an alternative store. It could happen for the Snap Store as well.
Yeah, earlier, and you may have actually explained this, and I just didn't quite hear it. But earlier you mentioned, I think it was on the manageability slide, about how user with sudo can't just like download a random version of LS that does something totally differently. I was just curious what the enforcement mechanism for that specifically was. Is that through Snap, or is that through AppArmor, or like how does that get enforced that it's going to only run that?
So, well, Snaps do heavily rely on AppArmor, but in that particular case, like if you're trying to drop in a user bin ls, right, in that directory path, that file system is read-only. You can't put a file there and replace the existing one because it's read-only. So all of those sorts of things are read-only. It's completely immutable. If you did, for somehow drop something in a location where something could try to execute something, actually the snap would fail to launch because the signature doesn't match anymore. So a snap itself is actually a single squashfs file, which is basically a single file that can be mounted in a location, and it provides a file system. But it's a single file, and if the signature ever changes on that squashfs, so at runtime it mounts that squashfs file into something that can be executed. The files inside of it can be executed. Snap won't even launch the snap if the signature doesn't match. So like if you try to unsquashfs Firefox, tweak something, resquash it, and coerce your system somehow to try to launch it, it would still fail to launch because the signature of that squashfs wouldn't match. So you can really trust that those bits are what they say they are.
Any other questions?
If I have a software package that's only currently available as a deb, for example, what would need to happen to run that on Ubuntu Core?
So in the current scenario, your best bet would be to create a container and run it inside the container. So you could create an LXD container of, say, 2204, install the deb there, and launch it, and it will work just fine. And in that case, it's unconfined, but inside that container. So everything inside that LXD container is kind of its own, segregated from the rest of the system that way. You could do that. The better alternative would be to repack that deb as a snap and contribute to the ecosystem.
What about software that, say, has kernel modules and other stuff like NVIDIA drivers?
Yes. So actually right now, that PC kernel snap does include the NVIDIA drivers. However, that's something that's being split out, and you'll be able to install those sorts of things as separate snaps. So like the NVIDIA driver could be a separate snap, and you can be assured that that version of that snap matches this kernel, and they will be updated in lockstep. That's, the terminology's changed several times. I think it's currently called components. Snap components is the terminology for that. And that's coming very soon. But then you could have these sorts of drivers packaged as snaps, and they will match. So things like DKMS, though, for example, are not going to work, which is where it would compile the module source at basically runtime, right? So, but in that case, you're actually tainting your system when you use DKMS, because any random thing could be very untrusted, and now it's in your kernel space, right? So those sorts of things aren't going to work in this sort of environment, but I would argue they probably shouldn't. Let's get them properly snapped in a trusted type of environment, published, vetted, and then manageable, so you don't suddenly have a kernel that doesn't support this anymore. Heather over here has a question. Oh, you got one back there?
Sorry. Two questions, real quick. You've got the Ubuntu Core. What do you expect to be the default applications, and how do you expect that process to work? And two, if I download it today, what's broken?
What's broken? Okay, so if you I'll start with that question. If you download it today, what's broken? I would say not much. I mean, things like, you know, I use my Bluetooth headset daily with it. Those sorts of things work. You know, it will boot. It will run most things that you want it to run. You know, there is some quirks here and there, like, you know, the Telegram snap, annoyingly, the app indicator doesn't pop up, and I haven't really debugged that yet. Little things like that you would expect to work, you know, may not. But for the most part, it does work. Like I said, I use it, you know, probably 2/3 of my day every day, and I have for like a year. It's pretty reliable. There is some scenarios where something that you want, you know, may not work, because it is running in a fully confined type of environment, and not all apps were designed to play that way. But it does work. And what was the other half of your question? I'm sorry. Default applications. So this is where every deployment will be a little bit different, but the ones that I've defined in our kind of our current reference build are Firefox for the browser, GNOME text editor. We have the, you know, cup snaps, which I think is, I guess, more infrastructure related stuff. Network manager as a snap. GNOME logs, so you can get, you know, log information easily without actually going to a terminal. You don't get quite the same terminal experience because you don't have a, you know, same level of access to your system, but we do have a temporary kind of solution called console, if you were installed today, that does give you some access. But having something like GNOME logs is handy. GNOME system monitor is included, and a few other random things like GNOME weather, a couple of GNOME apps like that. Not a lot, it's pretty light. Oh.
Okay, so Ken, I have two questions. Number one is, what is the status and plan on enabling people to provide debug symbols in their snaps, or like providing that for the kernel and then like the desktop environment, really important pieces? And the second question is there going to be like a core image for that includes like Office suite applications? Like there in the standard ISO, there's like a minimal install and like a full install.
Mm-hmm.
Going to be the same kind of concept for...
Yeah. Yeah, I'll summarize. So the first one is a question about debug symbols and snaps. Okay, that's a more complicated question, but I'll try to speak to that. Callahan may know more than me. But anyway, the second half of that, though, I mean, we haven't really completely defined what like a community release is going to look like for what the default apps are. I would imagine it probably would be beneficial for us to do something similar to what we do with Classic, where we have a minimal and, well, I guess full. We switched it because default used to be the full. But anyway, so we may do something like that where we have 2 builds that include those things, but also, App Center is included. You can easily install LibreOffice if you want it, So the question is there a lot of value including it or not? It's pretty trivial for us to add it, to have it's just a JSON file we could drop in. We could have 2 different images built. So we haven't really talked about that yet. I mean, it's still kind of a reference implementation, but that would be easy to do. The debug symbols question is a very good one. Mozilla's done their own thing with Firefox, which is working out pretty well, but a lot of it does rely on their infrastructure. We've got some work happening now. Do you want to speak to this, Callahan, or is he, okay? Oh, he doesn't have the microphone, though. Try to be loud, I guess. He's got it. Okay, I'll do my best.
Yeah, so for debug symbols for snaps are similarly going to be tied in with components that Ken was talking about. So when you build a snap, you can also generate debug symbols at the same time and extract them from your binary and put them in as a component. And then as a user, more likely a developer of those tools, you download the snap and then you also download the components with those debug symbols as well. It's not ready yet. It's something we're still developing, and you can join us on Matrix and try it out because right now you can build test components.
Okay, I'll try to summarize that. So really the solution for that is very similar to what I talked about with the kernel drivers being components. It's a new concept in snaps where you can build these components. So as a developer, you can create the debug symbols, and they'll be packaged in the component portion of that. And then to actually utilize those, you just download those components. What about a debug symbol server sort of solution? Are we going to use debug info D or whatever that's called?
Yeah, that's our long-term plan, but
Okay.
We're going to try and smooth out the components first.
Yeah. The first bit of that is actually getting the debug symbols into the snap. So yeah, that's been a long road to get there for the debug symbols, but I'm glad we finally have a path there. So more questions? We got a couple back here. I'll try to.
I got a voice. What are the advantages to Ubuntu's Core versus the other immutable operating systems that are popping up left and right these days?
Well, I mean, so yeah, okay. What's the difference between the benefits of Ubuntu Core versus some of the other immutable kind of offerings? Yeah, I would say the modularity is probably the biggest thing, and also really leveraging all. Snap's been around for a really long time, and there's so many benefits built in to just using your applications as snaps, your operating system effectively leveraging all those sorts of things. There's a lot of benefits there that those other immutable systems do not offer. But I also say the modularity, I think, is very compelling because generally with those, some of those other immutable offerings there's a giant, like say RPM OS tree that is one big chunk, and if you need to say install the NVIDIA drivers, you have to replace that big piece with another big piece that has the NVIDIA drivers installed. Or say you need to run some particular container workflow or something like that, that actually needs to be part of that. In our case, you could just install LXD or Docker as a snap, and it just works. You don't have to replace the root operating system effectively to make that work. You could just drop in the component that you want, and your workloads will work. So we have that modularity that the others really don't. We've been working on this for a really long time. I mean, snaps have been around for a very long time now, longer than Flatpak. We've built up a lot of technology here over the years. We started with focusing a lot of our efforts on IoT and those sorts of things, but in doing so, we've really built up kind of a portfolio of just great technologies, and it's all coming together now to really provide enough to run a desktop on. So it's taken us a while to get there, but I think the ability to have all those sorts of components and the way they interact together, I think is really the differentiator. I think you had a question too? Oh, same? Okay. Any more? Yeah.
Back in a few minutes, you said something about the terminal and console experience being different because of the access you had. Can you elaborate on what you mean? Like if I have shell scripts
So yes, I will say, well, I guess it's not important now, we're done. The real limiting factor is, so I mentioned, for example, that our GNOME desktop session is actually running inside of a strictly confined snap itself, right? So something like, say, a terminal that you launched inside of that, unless we had a fully snapped terminal that had all kinds of special privileges, but theoretically, if you launched a terminal inside that, it would actually be running as if it's inside that same sandbox that the GNOME desktop session is running in. So it wouldn't have access to anything else on the system besides the things that that GNOME session is using. So the scope of the terminal will be, predicted based on the environment that it's running in. So there's a few different ways we could solve this. Like, for example, we could snap some popular terminal applications and create some snapd interfaces that allow some special access to make it behave more like a classic system. We could certainly do that. I don't know if we will. I think the more compelling thing is to really harness containers. And if you need to run scripts and do things for your work that requires those sorts of things, you just open up, and we have a very nice app called, it's still experimental, but it's called Workshops, which is a terminal experience built on top of LXD, where you could say, with a click of a button, you have a Fedora container up and running. You have a terminal experience inside that Fedora container where you can run any sort of scripts you want. It feels just like any other terminal. You're just inside of that container. There's some other fun ones in the community. We have a fun contributor who's got LXD terminal. I see you, Ted. He created a snap of LXD terminal, which does a similar sort of thing. So we could have those sorts of things, but I really think the future there is leveraging containers more on the desktop to give you that developer experience where you need the powers to run any sort of thing you need to run. You can do that inside of your container without affecting the rest of your system. Like I said, it's not necessarily for tinkerers. If you like tinkering with your operating system that's running on your host system, it may not be the right solution.
The reason I was curious is you mentioned students,
Mm-hmm.
and it sounds, if you compare it to Chromebooks, like students strictly means students who are enrolled in programming. Like, is it not high school students?
Yeah. Well, but again, container workflows, right? Like you can imagine Visual Studio Code that's running on your system that has, compiling stuff or whatever it needs to do inside of these containers. You could have a, web development going on inside of a container and accessing it from the browser on your host. So you can do that sort of thing in a container without tainting the reliability of your system. I think that's the direction we really need to be looking in. But again, some of those questions aren't completely answered, which is one of the reasons why I want to gather feedback from more folks, right, to see what concerns people have. And that's why we're not saying we're releasing it for developers yet. We're working our way there. The problems that we know we can solve well, and then get it to the tinkerers later on.
How ready is this for someone who would be wanting to package a different desktop
Okay. How ready is this for somebody who may want to package a different desktop? I will say you could certainly do it now. You may need to ping a few of us for some pointers, but I am happy to be that person if you want to try to package a different desktop. Because so far we've only done GNOME, but I would really love to have at least one other reference to prove that it works. So which desktop are you thinking? Okay, let's definitely talk about that. Let's definitely talk about that. I suspect yours will be easier. He's got an unfair advantage. All right, any last questions?
So, would this be something that training at not a desktop show, but say fish be recommended for something like this?
Well, I'm sorry, repeat again?
So would this be a recommended use case for like changing the actual shell, the terminal? Would this be a use case?
To change the shell?
Yeah, like from bash to fish.
Doing that sort of thing? Yeah, so that's another one of those things where the terminal would need to provide the shell that you want. So like if you want fish instead of bash, I will say our current images we're building do not have fish, and they're probably not going to because some of that comes from that base OS, the root file system there, that's as a snap. But you could absolutely have your own terminal app packaged with fish included, or, again, back to the containers, spin up a container, apt-get install fish, and you're done. And when these containers are created, like you can map in your access to your GPU, your home folder, all those sorts of things can be mapped directly into your container so it feels at home. That's what I do today. All my containers are. So, Eggy.
Hey, so last at Ubuntu Summit, one of the things that came out of me meeting with all of the other devs for like Lutris and Spottle, well, not Spottle, but
Yeah.
Heroic and whatnot, we started working on a new project called ULWGL, and that leverages the same thing that Steam does in terms of using the Steam Linux runtime with Pressure Vessel, which is a modified version of VRAM, basically uses VRAM. How has there been any progress in terms of running a container inside a container? Is basically what I'm asking.
Okay, so any progress on running a container inside a container? His reference case here is like what we do today with Steam, right? So Steam downloads a pressure vessel runtime, and it basically creates its own container. In our case, we're running Steam in a snap, so it creates its own container inside of that. You have another use case that's very similar. You know, as a generic kind of case, that's complicated. Like we've had to do some special stuff in Snapd to make all the pressure vessel stuff work. I would argue we probably could make the Steam support interface a little bit more generic and make that work for what you're doing as well. So
we're basically doing the exact same thing that they're doing in terms of trying to get things to run the same across different platforms.
yeah, so
Literally pulling their runtime.
yeah, so precisely. I mean, maybe what we should do is actually look to make a more generic, not call it Steam, you know, type of interface that allows all of that stuff that's necessary for pressure vessel, and then it could be reused for snaps that are leveraging your framework. So let's talk about that a little bit. I mean, I'm here today and tomorrow. Let's chat. I think it would be very compelling. So I'd love to hear more about that. So, all right, I think we're out of time. Thank you all. I appreciate it. Hope you enjoy the rest of UbuCon and enjoy your lunch.
Thank you very much for that. That was really good for me. I've been curious about this since Nathan first drew my attention to it. It was well done. We do have a 1-hour break. Enjoy. 2 o'clock back here for orchestrating your home devices with Juju.
check, check. All right, sweet. Hey there, everyone. Welcome back from lunch. We're just going to give it a couple minutes here for more folks to kind of pop in as they get back from lunch. So excited to have you here for the afternoon session.
Yes. Thank you all for coming back. I hope you had a great and filling lunch. We have some more talks for you now, so you can fill your brain. So our next talk is Charming Your Home Network with Juju, and presenting that is Alex Lowe and Callahan Kovacs.
All right. Thank you, and welcome, and thank you everyone for coming to our talk. Like you said, I'm Callahan Kovacs, this is Alex Lowe, and we're here to talk to you about charming your home network with Juju. And a little bit about us before we get started. Alex and I are both software engineers at Canonical on the StarCraft team. And as you can see by the wildcard glob, the StarCraft team works on Charmcraft, Rockcraft, and Snapcraft. And these are all, of course, packaging tools used to package different things. And just a quick overview of those. Snapcraft, which you're probably familiar with, is our most popular tool for packaging IoT and desktop applications. Next, Rockcraft is for packaging container images. So this is similar to using Docker to make a Docker image, except Rockcraft makes OCI images. And most relevant to this presentation is Charmcraft, which is used for packaging server applications and the operations code for those applications. And we'll get into more detail about that shortly. But before we go any further, let's talk about you. Who are you? Perhaps you just want to run an application at home, like a media server, and you're not particularly interested in the installation or the maintenance. You just want it to work. If this describes you then Juju and Charms are not the right tech stack. In this case, just use the app's recommended installation methods because they work, they have the most support, and they're the easiest to use. So we're not here encouraging you to move to Juju if you have something that already works. But perhaps you're someone who's heard about these technologies like Juju and Charms, and you want to try these out at home and experiment with them, but you're not sure if it's even possible or what charms you would deploy at home, because when you look online, it's things like telco apps or a Grafana, things that maybe don't make too much sense to do at home. Well, if you can relate with person 2, then you've come to the right talk. We're here to show you how you can experiment with charms at home with apps that you would actually use at home. In this presentation, we're going to demo Juju and LXD to deploy some common home server apps. So we'll show QBitTorrent, the torrent client, OpenVPN as a VPN client, Home Assistant for home automation, and Jellyfin as a media server. And we're also going to show you how you can charm other applications and how to contribute to the ecosystem.
Yeah, so a quick note on that. Juju has sort of 2 types of charms that you can run. You've got machine charms and Kubernetes charms, which are roughly what they sound like. Machine charms can be virtual machines, machine-like containers like with XD. They can even run on bare metal hardware, just depending on what Juju backend you're using. Kubernetes charms are specifically for a Kubernetes pod. So a machine charm, the charm runs as root in this machine. So you can install software, you can add repositories, and anything that you need. The Kubernetes charms have access to Kubernetes. They can manage containers and images and stuff like that. So it's a difference between a vendor agnostic, all of my cloud VMs as code, and vendor agnostic, all of my Kubernetes stuff as code. But Juju can handle both of them.
And a few disclaimers as well. First, this is a proof of concept. This is relatively new area of interest, and in the charms we created for this demo, there's plenty of missing features. And then second, the tools like Juju are certainly overkill for using at home, and that's okay, because that's not exactly the point. And speaking of Juju, let's talk more about it. So Juju is an open source tool to deploy, integrate, and maintain cloud applications on any infrastructure. And when I say any infrastructure, I mean any infrastructure. As you can see, Juju is designed to run on many different backends.
This isn't even a complete list.
And it abstracts this. So when you write a charm, there's no backend specific code to deal with. The only exception to that rule is what Alex just described, is that there's two categories of charms, the machine charms and Kubernetes charms. For our deployments, we chose LXD as the backend, which is a tool to run containers and virtual machines. Some of the advantages of using this is that it's lightweight, it's easy to use, but the downside is that its integration with Juju is primarily for local testing, so some of the features available in other backends aren't implemented for the LXD backend. And now Alex is going to show us how to bootstrap Juju with LXD.
Yeah, so top right corner there, I'm going to be running htop, so you can see what system resources it's running. I am going to do this inside of a brand new Ubuntu 22.0 for virtual machine. Can I play?
Oh.
So the first step is just creating that virtual machine with 4 CPUs and 8 gigs of RAM. And you'll see sometimes a 10x or whatever flashing. That's just because I don't want to bore you with my slow internet. So we've got this machine. The first thing we need to do is update to the latest LXD. The Ubuntu 22.04 comes with the LTS version of LXD. Makes sense. So LTS Ubuntu comes with LTX LXD. But we do use some features that are only available in newer versions. So just downloading that. The second thing to do is to install Juju. And hey, look, it's a snap as well. So pretty standard install so far. I actually also have Juju running on this laptop. So if there are questions later on, I can do some live demo there. Juju is a strictly confined snap, so comes with all of the pros and cons of that. So I'm initializing LXD there, and then literally just running Juju bootstrap LXD. This will create a machine inside of your container inside of LXD, which actually runs the controller. One of the cool things about Juju is you don't need any additional infrastructure to manage these clouds. It will manage itself from within whatever cloud you're doing. So that was it. We have Juju up and running on this blank machine.
Now, what else is Juju? It's an orchestration engine for software operators or charms. And with that said, let's talk about charms. Imagine you want to deploy an application. There may be a lot of steps. You have to install it, update configuration files, and then enable and start services. And then when it comes time to upgrade that application, you'll have another set of commands to run, stopping the service, backing up configuration data, and then doing the upgrade and restarting. And if you're doing those things often enough, you're probably going to write a script for them. Now, what if there's a way for everyone to come together and collaborate on those same scripts to operate an application? Those scripts would be configurable and extensible. And what if there was a framework for those scripts to ensure that they were consistent and testable? Well, that's what a charm is. A charm is just a package of these operation scripts and tests. So in other words, charms are packaged operations code for an application. And this brings us to Charm Hub, which is the official repository for charms. It's similar to Docker Hub, but for charms. The source code for charms are hosted somewhere else, like GitHub or GitLab, but the charms themselves are posted on Charm Hub. And Juju can automatically download charms from Charm Hub when you're going to deploy. And finally, we have Charmcraft. Charmcraft is a tool to create, build, and publish your charms. So Charmcraft can create an initial template for your charm. It will build it in a clean and reproducible environment. It will provide ways for you to test your charm and allows you to publish to Charm Hub. And it has the same user experience and design language as Snapcraft and Rockcraft, so if you're already familiar with one of those other tools, you can quickly learn how to use Charmcraft. Let's look at what's inside a charm. Starting from scratch, Charmcraft init just creates a simple charm from a template. And first we have the charmcraft.yaml file. And this is where you define metadata like the title and summary and description, but it's also where you define the build process. Charmcraft organizes the build process into a series of parts. For example, you could have a part that clones a Git repository and builds a Go application from that, and another part that builds a Python application from code in the source directory here, and then you could package both those together in your charm. Now, even though you can do that, you probably won't. Charms are definitely the simplest artifact of all the craft applications the StarCraft team manages. So even though it provides this flexible and customizable way, most charms don't do it. They just will have a single part that uses the Python code in the source directory here. Next are the license and README files and requirements, which are self-explanatory enough, so I'll skip those. And then we have the source directory where the operation code lives. And Alex is going to tell us more about that in a moment. But finally, we have the tests. And when you first initialize a charm, these are just stubbed out tests. But this emphasizes that charms are built with good coding practices from the start. And coming soon, Charmcraft will have a way to do more comprehensive end-to-end tests as well.
Yeah, so this is a screenshot of my favorite text editor with the OpenVPN charm that I'll be demoing later. It's just a pretty standard Python class there. The only real magic is here in the init, where you use the operator framework that Canonical provides to tell it to observe certain events. So Juju is fully event-based. In this case, the events we're observing are the install event, the config change event, the start event, and the stop event, which is, I feel like those are all self-explanatory and kind of the minimum set of what you want to be able to do with a service. Going into the uninstall, some might notice that I'm literally using subprocess.run to do apt-get update. Again, this charm is basically a script that runs as root in your machine. so OpenVPN is already in the Ubuntu repos for me. I don't need to do anything fancy to get OpenVPN there. So why not just build on top of what's already there? Everything else is just managing that systemd service and handling things when you pass a change configuration from some client, well, some administrator's client machine somewhere in the universe to this charm. Everything else is just system control start, system control stop. I'm sure everyone's familiar with everything that's happening here. So we've got that charm written. Now I'm going to package and deploy it. Same structure on the screen that I showed you before. Yeah, come on, network. I think funny cats deserve priority, so I totally get that.
Try turning it off and on again.
What if we try just going back? Come on.
You could try just the Wi-Fi too, maybe.
Yeah. I thought that connecting to the Ethernet was a great idea, but well, I was on the Ethernet. I'm just going to switch to Wi-Fi.
I can hold that.
Oh, there we go.
Oh.
Okay, so I'm literally running Charmcraft pack in the directory. This sets up a container that has just a basic build environment. So first time you do that, it'll take a little bit of time, but that container does get reused. Took about a minute to do an initial build there for me. Then I add a model in Juju for whatever I want to call the model and deploy it. I deployed it with a I deployed qubit with a bit of configuration. This varies from charm to charm, so you'll have to look at the charm docs. But that fired up a LXD container for me, installed qubit torrent, and set up the web interface and everything. I got to set my own username and password there, and look, I'm downloading Ubuntu. So in that case, I was downloading the Ubuntu torrent. Sorry. We support Ubuntu LTS, CentOS 7, and Alma Linux 9 currently as the machines that the charms can run on. So but then it's per backend how that gets downloaded. So like LXD will download the Ubuntu image once, and then we'll just use that to fire up new containers. Yeah. No, but we do. But we will be happy to accept PRs. I am the maintainer for Charmcraft. I'm definitely happy to accept PRs on that front. So another example, let's say you want, now you've got your BitTorrent client going, you want to host some home videos for yourself and your family, some funny videos of your cats. We've got Jellyfin here already available. So this is, I made a model, just each model is, things within a model interact, things between models, there are additional layers to that interaction. So I made a model, I deployed Jellyfin from Charm Hub. It was three commands, and as soon as in this case, the Charm actually uses the official Jellyfin apt repository. It adds that into the machine, and then it installs Jellyfin. But then in the end, I've got Jellyfin there. It defaults to using /srv, and we've also got some other charms online that let you mount a network share to /srv, so that you can use your home NAS as the actual location for serving that. Now, one more thing is that sometimes your ISP really hates Linux ISOs, and so they won't let you use BitTorrent, because as we all know, Linux ISOs are the only known use case for BitTorrent. So then you might need to set up OpenVPN and put a VPN client on it. Can you rewind a little bit to about 15 seconds in? Actually, pause there, yeah. Pause there, please. So in this case, I am installing the OpenVPN charm, and I'm telling it to deploy to machine 0, which is the same container that already contains my qubit torrent charm. So when it's doing that, it will fire up OpenVPN just for that container. You can. And it won't affect any other machines in Juju, or indeed the machine that's hosting it. So now I can once again download Ubuntu, but just checking that I'm using the tunnel interface, and this will then make sure that qubit torrent uses that tunnel interface. That tunnel interface is being set up by my configured OpenVPN charm. And so when I download Ubuntu again, I'm very thankful to whoever was seeding that Ubuntu ARM64 torrent that particular day, because I downloaded it about 10 times. I'm taking just a little moment to get a few peers there, not revealing anyone's IP address, but this presentation and the videos will be available so you can check more thoroughly later on. But all of this is going through my VPN endpoint. None of that traffic is actually going directly to the stuff, just to prove that it's actually using the VPN. That's kind of important.
All right. And in this next demo, we're going to be showing Home Assistant. The deployment is similar, but what we're going to show at this point is one of the limitations we ran into. And with most backends, with Juju, if you want to expose your application to the network, you'd configure the ports when you're building the charm, and then you type Juju expose when you're deploying it, and that would expose those ports to the network. Unfortunately, that feature is not yet implemented for the LXD backend, so we kind of have to do this manually. And so here, I deploy it, I immediately list my containers, and I see the first one, which is where Juju itself is running as a controller. And then a moment later, you can see it spawns up a new container, which is where it's going to deploy Home Assistant. And all I'm doing is just doing a backend specific command here, so I'm exposing a port for this container. And then I'll just do Juju status and wait for it to finish installing.
In this particular case, Callahan used the Home Assistant Snap.
Yes, and I'll talk about that too in a minute. But yeah, and then Home Assistant is right there, so I'll just breeze through the setup and the login. And there you have it, Home Assistant as a charm. And like Alex just mentioned, Home Assistant is available as a snap. So one of the interesting things that you can do is if something is already snapped, it's really easy to charm because all the work and the details are already taken care of there in the snap itself. So if you're interested in charming something, I recommend you check if there's a snap for it already because you could have it deployed in truly minutes.
Easiest way to make a charm is to charm a snap. Second easiest way is to charm something that's already in the repos. So, speaking of which, we're starting a little organization on GitHub. It's called Charming Cottage. If anyone's familiar with Snapcrafters, I'm sure most people here are familiar with Snapcrafters to some level. We're kind of trying to do the same sort of thing, but only for charms for your home for home stuff. If you want to charm something that runs on big iron servers and whatever, that's wonderful. Highly encourage it. Charming Cottage isn't the right place for it. If you want to charm, I don't know, Pi-hole, and run a charmed version of Pi-hole for yourself, one, good luck. We both failed to properly charm Pi-hole. It does a lot of really confusing stuff. But two, yes, this is the right place. We will be happy to host that charm, to provide help for you. Anything that you're wanting to do for like home use stuff, Charming Cottage is there. We've got discussion forums available, and yeah, if you want to play around with Juju on your home network, this is probably the easiest way to do it.
And all the charms we demoed and more, we already have on this organization. So with that said, thank you. Any questions? Yes, go ahead. Thank you.
Thanks. So just had a question about how someone coming from the enterprise where we don't, unfortunately we don't use a lot of, fancy tools, how would somebody integrate something like this? So I saw that you guys talked about Azure. How would this all integrate?
So Juju is basically a level above your cloud, if you will. So let's say you've got a bunch of stuff, both in Azure Kubernetes and as a bunch of Azure virtual machines. You can bootstrap a Juju instance in your Azure stuff, and you can start migrating VMs and Kubernetes pods into Juju, which is a matter of making sure they're properly defined for Juju, so that Juju knows what's going on with them, and then just telling Juju and manage this by deploying the charm. Easiest way to do that, honestly, is get charms of what you're doing, deploy a new machine with the charmed version of and then just migrate over. But that can all happen inside of that same cloud.
Yeah, and to build on that too, I think that one of the goals with this too is that it is hard to bring something new to the workplace. And so many of these open source tools, it's things that developers play with at home, and then they want to bring it to the workplace. And yeah, it can be very challenging. Yeah, especially with bigger tools like this.
Yeah, the point of Charming Cottage is to get you familiar with the Juju tools and stuff like that are in honestly a low stakes environment, because if you mess up your personal streaming server, well, darn, you can't watch that home video again tonight. So.
I noticed when you were doing the Charmcraft init that it created a good amount of Python files. Is Python the only language that is supported by that?
So, I'm going to say yes and no. Python is the most widely used way of doing it, and the operator framework is written in Python for Python objects, stuff like that. But you know how an OCI image is just a fancy tarball with the different layers? A charm is a fancy zip file with each of the events being any executable that can run on that system. So we have charms that are still running within Canonical that are a set of bash scripts within a zip file and then a couple of YAML files to give the metadata. You can do that. If you wanted to, you could write the actual event software for your charm in Go or Rust or whatever, and Charmcraft can pack all of that for you. It will be a little bit steeper learning curve. I would recommend that for one's first charms at least, use the operator framework and what's provided. But once you're familiar, please do weird stuff with Charmcraft. Please break it in weird and wonderful ways, and please send me many very detailed bug reports.
Yeah. So yeah, I definitely will agree with your comment there, where you can do like bash-based scripts, but basically, you have like a dispatch script inside your charm, and then you can write that in any language you want. But I do find the one benefit of like using like the operator framework and using Python is that it's very easy for like other people who are familiar with charms to contribute, because you basically have a common standard language for being able to kind of collaborate together. So start hooks behave the same way, configure hooks, all that, and even custom events as well. So one thing that's really interesting about charms is that they can basically share libraries. So similar to say like Python package dependencies almost, they can share libraries. And then let's say like, you want to integrate like an identity server, like you want to have, I don't know, Linux users for all your family members in your house. You could then like take a library from like one of those LDAP charms, and then you could put it in like your Home Assistant or something like that, and then they would be able to kind of speak a common language that allows them to be able to configure and kind of mount yes. But I also did actually have a question, but I wanted to know, how long did it take you to put together all the videos and the charms for the Home Assistant and whatnot?
The charms took us a little while because we were experimenting with a lot of stuff. The videos that I did all of that in a weekend.
Yeah, we have tried quite a bit. Alex spent a bit of time using OpenStack, or trying to set up OpenStack for this as well. And
I struggled to get OpenStack running at home, but then again, this is also someone who has managed to install Gentoo, but not Arch or SUSE.
So I noticed Charmcraft init also creates some unit tests and some integration tests, just some boilerplates for those. Are those ran when you're creating the charm? Are those ran when you're actually deploying it? When are those ran, and what are the use cases for those really?
So the full template for, that Charmcraft init gives you includes a tox.ini file that are preset to run your unit and integration tests there. It also includes static linting with rough and MyPy. Is it MyPy or Pyrite? think we use Pyrite on it.
I'm not sure.
So you would use Tox to run those. We have an upcoming feature that'll be a Charmcraft test command, which will then run not just those unit and integration tests, but developer-defined end-to-end tests where you have the packed charm and you're running that inside of a Juju environment, doing certain poking at it, etc. To extend on what Jason was talking about too, I am currently trying to figure out how to detach Jellyfin from its database so that I can use the charmed version of MySQL or Postgres as the database for the Jellyfin charm. And I'll be using then the database integration libraries for that, so that I can run the database on a separate machine.
Yeah. And
the more detaching of such things that you do, aren't you running into the possibility of getting to situations that the original vendor had never in their life tested for?
I am. This is why we gave that caveat up front. None of the projects that we're doing this for are. Maybe one of them's aware of it. We certainly haven't told any of them, hey, we're trying to do this, and we're not trying to make this the official way to do it. I'm doing that for my own interest in using that for Jellyfin, not.
I've heard that Home Assistant people can be rather belligerent against people who are trying to repackage their software.
Yeah, we've seen that, and what we are trying to work with on things that are as big and complex as Home Assistant and as Pi-hole is rather than trying to repackage what they do every time. Work more on providing this charm that will use their official packaging if at all possible. So I've got a work in progress for Pi-hole that actually uses their install script inside of the charm. Their install script is very much designed to be user interactive, and charms are very much not. So I'm doing some weird hacky work to work around that. But the preference is definitely try to use as much of the official stuff as possible, and charms are a way to wrap that into something that is fairly standardized. Any other questions?
all right. Well, thank you very much, everyone.
Thanks, folks.
Okay, so we have a bit of a break here, and at 3, if you wanted to learn how to use superpower computing to do science, you will be in the right place. We hope to see you back again here at 3. So get some water, stretch your legs. We'll see you all soon. Since this is a bit of an extended break, if you want swag, we do have some more stickers and I think a couple mugs and journals. Now's the time.
Yeah, it's on. Okay. Hello, hello. Can everyone hear me? Okay, sweet.
Okay, so our next talk is Accelerate Your Time to Science with Ubuntu and Open Ondemand. And this will be given by none other than our own Jason Nucciaroni.
All right, thank you, Nathan. So why don't we get started in here? First of all, thank you all for being with me this afternoon. So yes, the title of my talk is Accelerate Your Time to Science with Ubuntu and Open Ondemand. So first things first, just a little introduction. If you weren't here for the impromptu sort of talk that I gave this morning, my name is Jason C. Nucciaroni. I am an HPC engineer at Canonical, and I am one of the not-so-ancient elders of Ubuntu HPC. And so if you're kind of, wondering what is, Ubuntu HPC, what does that acronym mean? At least for the first 2 years, I was like, oh, everyone knows this. But then I quickly got reminded that sometimes when you don't have the proper context, acronyms are a bunch of nothing. So give a quick little definition here. What is high-performance computing, and why exactly should you care about it? It is a paradigm where you utilize, supercomputers, computing clusters, and grids to solve advanced scientific challenges. And so, you would think like, oh, what industries specifically leverage this technology? Who uses it? Well, it's pretty much everywhere, almost. It's like you actually probably come into contact with like an HPC system or something that was trained on an HPC system every day. So some examples of possible industries where HPC is really popular is like aerospace, so they can use it for like modeling jets and whatnot. Agriculture, they can kind of use it to predict weather trends, kind of understand, how to plant crops, what are potential threats, like, if there's a wildfire, mass flood or something, how much could they potentially lose and what is the impact that it could have on the local food system. And then it's also used in finance as well, so it can be used for like advanced prediction, fraud detection, and then also just kind of modeling potential future financial trends based on kind of various compounding factors. And then if you see that QR code there, if you go ahead and scan that, that'll just kind of take you to a page on the Ubuntu website that'll just kind of go over some more use cases of where high-performance computing is really popular for use. And so then the next thing that's probably like is, what does Ubuntu have to do with high-performance computing? And what exactly is Ubuntu HPC? So here, Ubuntu HPC is one of Ubuntu's newer community teams. We've been around for almost a year now. Our one-year birthday, I think, will be in May. If you can read the text on the front there, basically if you go to our team page, I think it's on both Launchpad and on the Ubuntu community website, it's just basically a definition of what we work on. And so mostly our focus area is, how do we make Ubuntu a better operating system for doing high-performance computing? And to kind of give a little bit of context about how this community team, came into creation, it actually started at the 2022 Ubuntu Summit. Two organizations met. Obviously, the first one was Canonical, and then the second one was this other organization that specializes in doing high-performance computing on Ubuntu called OmniVector. And so at that point, Canonical, at least me, we were working on doing HPC, so we were doing packaging, writing some Juju charms from the previous talk. Also, once again, packaging, just lots of packaging. And then, we kind of got talking, we kind of realized that we had a lot of common challenges. And then at that point, what you see on stage left here is Ubuntu HPC. That's kind of our community logo right there. We decided to start a community team that was kind of open for anybody to join and contribute. So you might be asking yourself, if you're thinking back to the title of the talk, what does Open Ondemand have to do with Ubuntu or HPC? So, when you think of a supercomputer, you look at a picture here, and you can see, what do you see? You see a lot of computers. And so supercomputers are massive machines. So you think your laptop, will think that you have an entire building dedicated to just running a single computer. It draws many megawatts of power. You actually have to build it in very specific places because not every power grid can support running an HPC system. And you have thousands of compute cores. You have thousands of people who are all using resources on that system. And so then, maybe some not so humble artwork here. This was made by a friend, by the way. I didn't, make this myself. But you think like, oh, I have access to such a powerful system that, I'm basically going to be unstoppable. I am going to create things, science and math are, I have masters of that, and nobody can stop me. But an often problem that I find, at least in my early years of HPC when I was a consultant, is that most people, they start out feeling like this, and what ends up actually happening is this. So yes, so why do most HPC users, even though and don't get me wrong, they're very bright and smart people, they're like PhDs, leaders in their field, they know how to do everything, they're masters of biology, they're masters of genomic analysis, and yet we all kind of have this Patrick accidentally nailing a board in his head moment. And I'd like to maybe make the assertion about why they struggle to use supercomputers is because of this. Or actually, wait a minute. Oop, they got a little outside. Okay, so HPC is everywhere. And so, a majority of individuals struggle to get started. So why are some possible reasons why new users could, struggle to use HPC systems? So I kind of alluded to this a little bit earlier. But what I wanted to specifically mention is, some maybe naive reasons of thinking, or at least, easy areas to point at. So the first one could be is like, oh, do people just struggle because it's a different tech stack? So, most maybe modern computer scientists are very familiar with, say, like the Python programming language, but in HPC, languages like C and Fortran are much more prevalent and much more used. You could also maybe, make the challenge that there's a lack of adequate new user training. I often find that most HPC institutions actually have very excellent documentation on how to do use cases. You could also maybe challenge is like, maybe they just don't understand the problem they're trying to solve, and they don't understand how to correctly model that on the computer. You could maybe say it's like the system too advanced for these noobs. Or you could say like, are they just lifelong Windows or Mac users and they're just not familiar with the Linux environment, or they're just not very smart. And so what I kind of gave a little bit of a sneak peek to in the next slide is that I'd like to make the assertion that what the problem really is this, the terminal. And so you might look at the terminal and say, why does this guy up here on the stage think that the terminal is the problem? Well, maybe a rough show of hands. You don't have to raise your hands if you want. But how many people would get the idea that they have access to a supermassive computer that is capable of solving the most advanced problem that you can think of if all you see in front of you is a black box that's telling you to type something? Who thinks they could figure that out? Okay, so, all right, who's been using Linux for like 10 years? Show of hands. Oh, all the same people. So, yeah, so you don't even know what computer you're talking to from that prompt, and that's kind of a problem, is that it's very hard for the user, or a new HPC user who doesn't have 10 years of experience with Linux like most of this room here. They're just trying to get something done because either A, their principal investigator, or even their boss, or even maybe they're just trying to test something out, try something new, and they just, they get access to a supercomputer and they say like, type these things, click a couple buttons in like say PuTTY or another SSH program, and you just get given this black box. And so that's kind of what the problem is that, you can look at it and say, in the beginning, there was the shell, and so now here's the case against it. And so why might the shell or the terminal not be the best entry point for new HPC users? Well, first, you can kind of think of affordances. And so if you're not exactly familiar with what an affordance is, it's basically, a device, maybe say like a phone or a laptop or even your car. An affordance is like it telling you that it's capable of doing something. So you think like a steering wheel, you can steer the car with the gas pedals, you can accelerate. And so with an affordance, when you go into the terminal, what it tells you is that you can type something, but what it doesn't tell you is what exactly to type, how to efficiently type it, or how to do anything correctly. And then the second thing is that, the terminal can be kind of a learnability challenge. And why can it be a learnability challenge? Well, if you don't even really know what the terminal is, like, if you're maybe like 6 years old and just open like the terminal on, your Mac laptop for the first time or something, the shell and its complementing scripting language doesn't necessarily teach you anything right off the bat. And so the idea is that if you want to learn something new, you have to know the right places to go. Like you have to know how to open manual pages. You have to know how to use the internet, how to search. You need to be able to go into Stack Overflow and, who's blowing smoke and who actually knows what they're talking about. And so how do you learn what you don't know if you don't even know how to learn what you don't know? And then the next thing you could also kind of argue against the terminal is consistency. And so the issue with the terminal being consistent, not necessarily say the user interface of it itself, but if you commonly look at a lot of command line applications, you find that depending on the framework that they were written in, they kind of have a very specific style guide. So, I guess kind of the low-hanging fruit here that, I could kind of pick on about usability is that not every CLI application kind of has the same interface for just kind of getting the help information. So, some commands, they only support the short option, -H. Some only support the long option, like double help. And then some, they actually have a built-in help command that then offers extra, information for the subcommands. But it can be very frustrating when you're first starting out and you think oh, every application takes this --help option, and then some applications don't even actually offer a help dialog. And then the last thing is, kind of visibility. And, what do I mean about visibility in the terminal? I basically kind of allude to it as it doesn't really show you what to do next. So let's say that you go online, you get something correct, like how to read a file. Well, what do you do after that? How do you copy that, say, into a clipboard? How do you, maybe pipe that out somewhere? How do you further process that using grep or something? Or how do you, move data around from one directory to the next? It doesn't really tell you what to do. And so now that I've kind of maybe railed against the terminal a bit, you're likely asking yourself, so what exactly is Open Ondemand and what does it do? Well, Open Ondemand is an interactive portal for accessing HPC resources over the internet or through your web browser. And so essentially what Open Ondemand, and if you scan the QR code there, it'll take you to their main website, it is a web-based application that kind of moves beyond the terminal, that I like to say, and it kind of now focuses on providing a visual interface for taking advantage of your HPC resources. So, okay, I saw some people scanned it. But now, yeah, basically what it is a web portal, and so what I have here is kind of some example screens of what Open Ondemand specifically is. So for here, the best one that I really like to show is that it's just basically an interactive interface for figuring out what's going on with your cluster. So here, what this screen is showing is listing jobs. So typically in HPC systems, not everything is totally synchronous. Typically, will happen is that you submit up to, say, a scheduler or something, and at that point, then that scheduler is responsible for deciding when to run your workload based on available resources and other constraints. And so in that case, what this screen is doing is effectively showing you where those jobs are. But now if you did it, say, in the terminal, it would just basically be your job submitted. And doesn't tell you anything else. It doesn't tell you if it's running. It doesn't tell you if it's queued up. It doesn't even tell you if it's actually good enough. It could get totally rejected, and then you're just kind of left wondering what happened. And so, there's quite several benefits of using an application like Open Ondemand for accessing your HPC resources. So for example, the first thing that I really like about it personally is that it has support for interactive applications. So it's not just Open Ondemand that you're going ahead and running on your system. So for example, you can get graphical interface to a lot of really popular data science applications. So some of the examples I have listed here is Jupyter. You can use Open Ondemand to queue up Jupyter sessions on your supercomputer. You can also use it to queue up VS Code server. So for example, if you want to develop code directly on the system, so if you're someone here who's really flexing their H100 GPU collection on me, I saw him laugh, you can actually go ahead there. That's how I know it landed. But you can launch your VS Code server directly on that node and then take advantage of those resources right there. And then there's some other popular applications as well. So for example, there's Pluto.jl, which is a similar application like Jupyter, but it's dedicated specifically for the Julia programming language. There's also Shiny, which is web apps through the R programming language, which is really popular in data science. And then you could also look at RStudio, which is an IDE for the language. And then MATLAB, which is a popular application among scientists as well. And so then moving over to the next category of benefits here, you also get to take advantage of, say, interactive desktops. So one thing that's really nice about Open Ondemand is that it gives you the ability to get graphical sessions through VNC directly on your compute nodes. So if you're not really a terminal person, if you're not interested in going through typing in a bunch of text and kind of being a bash scripting king, instead what you can do is you can actually launch a desktop session directly on your cluster. And so in this case, some of the examples that I have here is default Ubuntu, so you can run default GNOME, and then it also has support for two other desktop environments, which is like XFCE, which I've also commonly heard referred to as Xforce. I don't know if anyone else calls it Xforce, but that's what I've heard sometimes. And then also Mate. So does anyone actually call it Xforce, or? Nobody calls it that? Nobody calls it that? Have I just been wrong this whole time? All right, okay. Yeah, and so then the last thing here, the last benefit that I really like to say is scheduler integration. So you could maybe argue that schedulers is a bit more specific HPC knowledge, but one thing is that everybody kind of has their preferred scheduler that they like to use. So some of the logos that I have up here, the first one is for LFS. That is a workload scheduler that is produced by IBM. And then there's Slurm, which is based off of the drink from episode 10 of season 1 in Futurama. I'm able to read that back because I get asked that a lot. What is Slurm? And it's like, it's a simple Linux utility resource manager, but they prefer that they don't call it that because they want you to call it the Slurm Workload Manager now. And there's OpenPBS, which is an open portable batch system. It's similar to Slurm, but it has some different syntactic differences. And then lastly, it also integrates with Kubernetes. So if you want to be able to run your jobs on your Kubernetes cluster, you just basically configure your scheduler there, and it'll go ahead and launch a container up. So that's pretty neat. And so now that I've kind of, maybe gone through the benefits of using Open Ondemand a little bit, oh, geez, I just noticed that typing error, but it's all right. It's like, how is Open Ondemand important to the Ubuntu HPC community? And so, to give a little bit of historical context here, if you kind of look at this diagram that has been through a couple iterations here, we, as a community in Ubuntu HPC, are currently working on developing this Charmed application called Charmed HPC, so Charmed High Performance Computing. And so exactly what that is that we're looking to leverage, say the work of Callahan and Alex here, using Juju and Charms and all that to be able to deploy a fully functional high-performance computing system practically basically wherever you want it. So it could be on like Azure Cloud, it could be on AWS, or even on a local LXD instance on your laptop. And so this is kind of the current architecture of Charmed HPC. So as you can see here, kind of on stage right, the first part is traditional way of accessing it is via the SSH protocol. You'll basically go into, say, like a login/headend node or a head node. And then that's where you'll see kind of that terminal experience where you're now on a host. And then you have the challenge of knowing, like, OK, what computer am I running on? How do I leverage those user resources? And how do I even know that I'm leveraging the best way possible? And then after that, kind of from that login/head node there, you're kind of then interacting with the job scheduler. So in this case, we have chosen to use Slurm as our job scheduler implementation. And so from basically that login/head node, you'll submit jobs up to Slurm. From then, which at that point, typically what Slurm will then go ahead is take inventory of all the available compute nodes, which are on kind of stage left here, and then go run the jobs on those. And so compute nodes can be typically composed of very different resources. They can be homogeneous or heterogeneous, depending on kind of the cluster's needs/architecture. So for example, here we have like the SPAC package manager, which is a like user level application that can bring in all sorts of different packages. Quite a great community. I love working with them. And then it can also have some optimizations for like network and whatnot. So you can choose to use like high-speed Ethernet, or you can also choose to use something like InfiniBand. And so then, now that we've kind of looked at what specifically Slurm is, now we have some other auxiliary applications that we have as well. So for using users, we use LDAP. That's just basically, I forget the acronym off the top of my head now that I'm on the stage, but we use that for kind of providing the identity and access management. So that's how we're able to make sure that users are the same person across every node on the cluster. And then typically we'll also have some kind of storage implementation, parallel storage, and that's basically how we make sure that files are available on all of the compute nodes. So let's say that somebody goes into the login head node and they submit a job and it goes to compute A, but then they also have another resource or another job that they need to run that also needs to use something that their job that on compute A is using. If it goes on compute B, it'll still be accessible and all that. And then you might see MySQL up there, kind of in the top there. What MySQL is mostly for is just kind of collecting cluster data and usage data. And then that way, it's like if you're a site admin or something, you're able to then just execute queries against that to see what your cluster's overall usage is, or find out if you're not charging your users enough. And then lastly, we kind of have two components. We have CAUS, which is kind of an acronym for Canonical Observability Stack. And so that's just basically a suite of tools for collecting metrics and kind of viewing metrics about your cluster. So for example, We could collect health information about all of the compute nodes, pipe that into the cause, and then you go to, like, say, a Grafana dashboard, and that'll tell you everything that you need to know about that compute node. And then the last thing is that we have Moz, which is like Metal as a Service, and that's basically our backing cloud implementation that we could use. We're able to slot pretty much anything in there, but in this case, Moz, what it does is it allows us to request like bare metal resources. And so now, with the sunglasses and finger guns emoji, charmed HPC with Open Ondemand. And basically how this implementation is different is that instead of having that traditional SSH login head node where you have that shell environment, instead, now you kind of then have another entry point that's through the web using Open Ondemand. So basically, you just have the Firefox logo there. You go into Open Ondemand, and then you're still able to kind of fully leverage your system's resources, so you can integrate with Slurm. You know, you still have the same users. You also have access to the storage that the cluster is using. Yeah, so it's pretty nice. So now the next question is that now that I've done a little bit of talking about Open Ondemand and understanding. So now where does the work currently stand on integrating Open Ondemand into charmed HPC? So this is kind of something that we've been working on as a community, is getting this application. There's quite a lot of steps. Open Ondemand has pretty complex architecture. So we've been making steady progress on it. And so, yeah, basically, you know, the short of it is that we're hard at work. Was still working on it yesterday when I was traveling here. So a couple of things that we have done, and some things in flight, and then there's other things that we're still kind of hammering out and working on. So the first thing is that we have a functional snap recipe. So we're able to get a successful building snap package that has all of the services that Open Ondemand requires. Later in this presentation, I'll show it, but it requires like 3 different web services. It's a bit interesting how that works, and we had to figure out how to cram all 3 of those inside a snap. And then also, we worked on developing some abstractions for configuration. Specifically, it has a lot of YAML configuration files. I think you can do up to like 100, depending on how granular you want to get in like the config.d directory. So we developed those abstractions to make it really easy to do that using snapctl. So if somebody wants to basically say like, oh, you know, I want to be able to, or I want like jobs to have this lifetime or something, you can directly configure that through Snap. And then we also have a working Apache HTTP integration for serving the web application itself, Open Ondemand. So Open Ondemand uses Apache as the primary entry point, and so we have that working now, so you're able to kind of start getting to some of the main interfaces. And now we kind of have the in-flight parts, and some of these are a bit complicated. So the first thing is that we have to now add a OpenID Connect integration. So basically that'll be for kind of the 2FA/login service. So we have LDAP working, but we need to be able to authenticate our users as they access Open Ondemand. So working on that. You'll basically be able to use any OpenIDC provider. We'll be starting with DEX, but then probably looking at like Ori Hydra. And then also, the other part that we're working on now is kind of the Nginx integration for running like user-confined web applications. So for example, like when Open Ondemand schedules and runs Jupyter, it's using Nginx to basically proxy that back to the user, and then it's confined as that user on the host, so that they can't just like, you know, be like, oh, I'm root now, and I'm going to delete all your data. And then 2 things that we kind of have slotted off for the future then is that we want to have initial support for a base set of interactive applications. So there's a couple of defaults that they recommend, specifically like Jupyter, VS Code Server, and then they have some other default apps available as well as kind of reference point. And then we also want to develop a Juju operator, which is basically a charm, and then that way it'll be really easy. All you have to do is like Juju deploy, Open Ondemand, and you'll have a fully working implementation. And so now one thing is like, okay, so why is like this work still in progress? Well, you know, I just want to give a little bit of an overview of the architecture of Open Ondemand. So on the kind of stage left side here, you'll basically be looking at the auxiliary services. So these are things that are kind of outside the domain of Open Ondemand, but things that Open Ondemand integrates with. And then on stage right, those are components that go into Open Ondemand. So kind of going from top to bottom here, if you look at the first part, you see the front-end proxy, and what the front-end proxy is that basically the Apache service that serves up the Ruby on Rails application that, you know, you kind of work through, a user would work through to request jobs, you know, log in. They can even get an interactive terminal if they wanted it, and also just like view status of services. And then kind of then beneath that, you have the per-user aspect of Open Ondemand. So in this case. What you have then is like that backend proxy. That's where the Nginx service that we're currently working on comes into. And then you have the application runner, which is Fusion Passenger. That's like a Ruby application for starting it, and then the application itself kind of all the way at the bottom. And so per user, what that is, they commonly refer to it, the Open Ondemand upstream, as per user Nginx process. It is responsible for basically queuing up user jobs, starting Jupyter, but then running that kind of under that user's namespace, and then that way, they can't accidentally access or, maliciously access someone else's data, and that's way, everybody is who they're supposed to be on each of the compute hosts. And then kind of then on the stage left side, you'll see the client, the authentication, so site-specific. Basically what that means is like whatever identity and access management platform you want to use. So you could be like LDAP, or you could be like Active Directory. The HPC scheduler, as you saw kind of in an earlier slide, that would be Slurm. And then like the nodes themselves, or the network file system for providing the parallel storage implementation. And so now you might be wondering, okay, so like where is our work coming in here? So kind of on the stage right side here, those are the components that are going inside the snap. So basically the front end proxy, the back end proxy, the application runner, and the application, or well, not necessarily the application itself, but parts of the application have to go into the snap. So the first part that we have that's really working nicely is the Apache front end service, or the front end proxy. That's working quite nicely. So currently now, if you install the snap, you can kind of be able to start navigating to some pages. And then what we're working on is kind of that per user aspect, which is like the back-end proxy and the application runner. But we do have Nginx and both passenger building successfully into that snap. And then basically now, the parts that are highlighted by kind of for Juju on stage left, those are currently, we have those available. So we have a scheduler implementation available. We also have authentication available. We have the node hardware itself. And then we also have the storage implementation. So really, it's about getting that kind of front-end part working inside the snap. And so there's been quite a few lessons learned during this process. I've at least been working on it since, since we released Mantic Minotaur, so back in November. So kind of the first title here, I guess a little bit playful maybe, but I ain't met no bug I can't squash. And so what we've learned along the way, maybe a bit bold there, but so, kind of the first major lesson that we learned is that we needed to bundle a custom Apache with OpenIDC inside the snap. So if you've ever used like the Nextcloud snap, you'll kind of notice that they ship their own Apache instance. And so we have to do the same thing. And so the main challenge with that is that Apache from archive does not stage correctly using Snapcraft, which I don't think is actually Snapcraft's fault, so don't worry about it. But yes, so it doesn't stage correctly, so there's some like Etsy alternative scripts that don't run right, so we have to build it ourselves, and then we also have to add the OpenIDC plugin as well, so that Open Ondemand is happy when users log in. Another thing that we also found is that we needed to build a custom passenger in Nginx, and so the main reason for that is that I believe the Nginx that we have currently in archive only has the Apache integrations, and then the other thing is as well is that Nginx itself doesn't support dynamic modules, so you have to compile them in statically. So that was something that we had to do. So basically, in the snap recipe, we have to basically pull down passenger, and then we have to go inside passenger, and then we have to pull down Nginx, and basically then we compile Nginx and point to some paths that are provided by passenger. And then the other thing that we found too is that Debian rules files can be your best friend for understanding how to properly stage and prime things with a snap. So I find that usually if I'm ever snapping something that's also available in archive, I just basically unpack the Debian package and then just look at that rules file. And then from there, I kind of have a good idea of like, okay, what needs to be in a configuration script, what needs to be in an install script, and where do files need to be copied inside of the snap image. And then also another thing is that source code can be the best source of documentation. I know common problem is people are like, oh, the documentation says one thing, but the code actually does another thing. And it's like, what? Documentation's wrong. Yeah, so in that case, what I really found is that I am very thankful that Ruby is so easy to read. Oh my God. So we had to take advantage to make Open Ondemand work inside the snap. We had to use some undocumented environment variables. So that might be interesting later down the line if we go to the upstream maintainers and say, hey, we're using these features, and it's like, oh, you weren't supposed to do that. And it's like, well, too bad. So it's all good, it's all good. But we found that source code can be the best source of documentation really because, you can quickly identify if like, oh, we need to author something ourselves, or if, maybe there's potentially an opportunity for us to make meaningful contributions upstream, or even at that, like understanding like, oh, the full feature set of the application so we don't need to modify it in our own way. And then the last thing is that, client libraries can really help reinventing the wheel and make it easier to manage various components. So if you actually do scan the QR code here, this is a small library that I authored that it basically just kind of wraps like a couple of core YAML file configuration files that Open Ondemand has, and basically makes it really easy to kind of be able to manipulate that information. And so how it's being used inside the snap is that basically if I want to say like, oh, I want to change like the server name for this instance, or I want to do something else, all I have to do is just basically do snap set on demand, and then just the configuration options I want to pass. And so now for a short demo, basically go really basic implementation of what we have working now. So I'm going to pop over here, exit out. Can I escape? Oop, I don't want to do that. There we go. I'm going to pull this here. And I'm going to make the text bigger in the terminal because I know that my text is too small. There we go. Sorry, I'm always like, you pre-record a video, and then you're like, oh no, I made the text too small, it's all grainy. So here we go. Can everybody read that? Is that good? Okay, sweet. Thank you. So first, what you'll see here on my terminal, it's just basically a simple Biobu instance. I hope I said that correctly. But what it is that I'm currently in the Open Ondemand project. So if I do like ls here, you should see some files. So, typical Git project. It has like the license, it has the README, it has the helpers aspect, which is basically just the configuration and installation hooks for Open Ondemand, and then the snap directory that defines the build. And then overlays is just some custom files that I basically copy in when I build the snap. And so for the sake of not trusting conference internet, I already have a pre-built copy of the snap. I've been burned before where it's like, oh yeah, I hope you don't mind having a megabit a second, which ended up not being great. So I already have a pre-built snap. And so what I'm going to do here is just do a little reverse search and push it into a example LXC snap that I have. And now we're going to clear that out. And then I'm going to shell inside the snap real quick, on-demand test. There we go. So now I'm in on-demand test. If I do a simple ls, I should see, oh yay, it's available. And so now what I'm going to do is I am going to do a snap install. So snap install. And then should be able to tab autocomplete. Nice. And then one thing is that I'm going to do dangerous. That basically just signals that I want dangerous, not angerous. Dagnerous, not that either. Okay, there we go. So we have dangerous. That just basically says that we're installing a local copy and not something from the store. And then classic confinement. And so the reason we have classic confinement is Open Ondemand actually qualifies due to the fact that it is an HPC workload orchestrator. So it manages workloads, not the machines themselves. And then there's also some aspects as well where it needs to be able to drop privileges to run as the confined user. So basically when you start Nginx stage or you run another job, it needs to be able to assign that process the user's effective like UID and GID. And so that's why we have that. So maybe Ken could prove me wrong, but I did that, so I guess I'm in the clear. But we do the snap install, so hopefully everything goes well, doesn't break. So you can see mount snap on demand. I also pre-downloaded a lot of the core snaps that I needed as dependencies. So the snap is built itself off of Core 22, so it uses all the libraries from there. And then also just like having snapd available. So now, if I go ahead here, I should be able to run a basic command that does open on demand or on demand update portal. So that's just basically the front entry point. So you can see there, it just basically quickly generates an Apache config. If you actually want to look at that, I should be able to change to the snap directory. I'll clear that so that everyone can read it. Var snap on demand, common. Ooh, let's go. And then, uh-oh, it's getting long here. UUD. Oop, not PPP, UUD. And then config. To be able to look here, and then you'll see, oh, what's the UUD portal YAML file? I should be able to less that. Hopefully less is available. There we go. And it's just basically a YAML file that specifies a couple parameters here. So for example, you could say like, oh, where to like put the access log for when people log in. You can also specify if you want to collect user analytics as well. We all know how everyone feels about not being able to opt into telemetry. And then we can have some user regexes, and then just like a couple common like URIs and redirects as well. And then if we change up here real quick, and then we just change into the Apache 2. Oop, I might have spelled Apache wrong. Change directory, Apache 2. There we go. And then we go into conf.d. Oh, I think I messed that up. No, I did not. Okay, and then we read the portal file here. This is the automatically generated Apache access file. In this case, since I have not set up OIDC, it does the rewrite engine, and then basically it will navigate the user to a file that says, hey, you need to set up authentication so people can't just log into your cluster and indiscriminately do things. So now if I exit out here, and I control L, and then I go back to home, I can actually go ahead and start on demand here. So I should be able to just do snap start on demand. And it should say started. And now if I grab the main IP of this server, which is 10.6.29, let me pull over a browser window real quick. I heard somebody laugh at me. There we go. And now I type in the IPv6 there. Welcome to Open Ondemand. It started successfully. It's signaling to you that you need to start. And then basically at this point here, the part that we're still kind of working on is being able to get that authentication information inside the snap, and then basically then get it started where it will take you to like a login page. So for example, just like username and password, and then even like a 2FA. So you could like go on your phone and be like, yes, this is my login attempt. And so one thing that I do want to point out here is there is a bit of a spelling error there, so I actually did make a pull request to fix that. Currently, it is not released in a bug fix, so they're still working on the next release. But once that's available, I'll be able to rebase the snap on that new version, and that spelling error will be fixed, which is pretty nice. I'm a contributor. OK, so now going back to the slideshow here, let's go now after the short demo. And so now you might be saying, after that I've showed you here, you know, what happens after this. This is kind of a rough timeline. So this is like the UbuCon at SCaLE logo that we did, which is like the penguin waving inside the circle of friends. I quite liked it. Credit goes to Aaron for that. And then I have a picture of a numbat for Noble Numbat release. And so you can kind of look at it and see like, oh, what are we specifically working on? So the next steps that we have is we're going to integrate Nginx stage, which is basically that utility for starting the per user Nginx process for the interactive applications. Need to get that working. The next part after that is getting the OpenIDC integration going. You can actually use Open Ondemand unauthenticated, but it's very clear that it's unsupported and not an intended way to use Open Ondemand, so I would not encourage it. And then after we kind of get that core experience working, then we're going to publish the snap to the snap store, and then that way people can start kind of pulling down edge release. We basically just don't want to publish it yet until it's actually working, because the last thing we want is everyone to pull down the snap and be like, your snap sucks, it barely works. And it's like, well, yeah, it's because it's not finished yet. And then the last part here is then creating a Juju operator to make it easy for site admins and charmed HPC users to effectively start Open Ondemand and easily bring it into their clusters with minimal configuration. And so now, if you actually want to see the source code, because you know it's open source, you can go ahead and scan that QR code there. I will apologize that the README isn't exactly my best work. We'll update it later, but yeah, if you want to kind of start getting like a preview look at like the work that's going on in there, you'll be able to scan it, see the Snapcraft YAML file, some of the other Python scripts that I'm working on for like the configuration and installation, and client libraries as well. And you know, kind of maybe the last thing here is a call for today. So as this is a project of Ubuntu HPC, if you are interested in potentially contributing, using it, or you're just kind of interested in tracking its development progress, I encourage you to join Ubuntu HPC. If you scan the QR code, it will take you to our community page on the Ubuntu website, and it'll just basically give some information on how to get started, as well as ask an FAQ. Because the big question we get is like, this is really interesting, but I'm not in any way involved with HPC. Can I still join? And the answer is yes. So yeah, if you have any questions also, yeah, feel free to get in touch as well. That's pretty much it for my presentation, and thank you for listening. Yes. Yeah, we have a microphone there.
So I'm not sure about this. Is this intended to be a user interface to existing data analysis programs, or are you hoping to take over some of the data analysis yourself?
So I'd say it's more meant to be like user-facing. So it's basically a web portal that allows them to effectively manage like the resources that they have available in their cluster. So for example, if somebody deploys like the kind of termed HPC core components, like the Slurm workload scheduler, effectively, if they were to deploy Open Ondemand, they would then have like an interactive web interface that allows them to access those resources rather than having to say,
because I would doubt you'd want to take on replacing those data analysis programs.
Yeah.
Many graduate students died for the sake of creating those programs over the years, and so if they have 20 years of understanding that this particular set of packages works well, they're not going to easily move to something else.
Yeah, so
as a user interface, you're probably okay.
Yeah, so for a user interface, it's definitely fine. And so maybe one thing I didn't really touch on that I could have a little bit more is that you can actually create your own applications that integrate with this front end. So for example, if they had, say, these codes that they've been working for like 20 years, like, oh, they have like a GUI program that they click through and allows them to kind of access maybe some libraries they wrote for data analysis. They could write their own interactive application that plugs into Open Ondemand, and then at that point, through the web interface, they can just basically go ahead and start it, clicking through a couple buttons and launching a session.
Is it good for interacting with things like NumPy and SciPy, because those are some of the main things
that
are
so
used for this?
It can be really great for that. If you're looking for like a development environment to use like SciPy or NumPy, you could basically just install inside a Python virtual environment and then access that virtual environment through like VS Code server. You could also install it into your IPy kernel for Jupyter. But the nice thing about it too is like if you actually develop through Open Ondemand and then want to like submit your jobs through like the traditional way using like the batch scheduler and all that, you can still do that because those libraries will be installed on the system. Is that kind of okay? Yes.
I noticed that you had a use case where the on-demand user would essentially go straight to a node.
Yes.
Bypassing the job scheduler. And I'm wondering, like, what kind of use cases that are you thinking about with that? Is there any interaction with the job scheduler to know that you're using these nodes? Is it the idea that the node's not in the cluster? Or?
Yeah. So the one thing that's nice. Without saying, potentially having like direct access to the node. I guess maybe let me walk it back a bit. So the reason why like the job scheduler kind of exists is that typically when you have a lot of these resources, users maybe don't effectively know how much, resources they need. So if they kind of go onto a node that's like super powerful, like say like an H100 or, massive core system, they're going to be like, well, I'm going to use all those cores even if I need only one because it's performance, right? And so basically what the scheduler kind of helps with that is kind of partitioning out those resources and constraining and confining. So then that way, what we kind of try to reduce is the issue of like noisy neighbors essentially, where it's like, oh, if you just give everybody direct access to all of the same nodes, you're going to have the problem where they're all going to want to use all of those 80 cores, and then they're going to be like, why is my performance degraded? Why am I getting all this like incorrect results or having all these issues? And it could just be because like the node is oversubscribed. So that's kind of the problem. And so the one thing that's nice about Open Ondemand is that it integrates with the scheduler. So like when you say like request an interactive session, like an interactive desktop, it'll actually make a request out to the scheduler, and then it will wait to start your session. Depends on the cluster utilization for how long it takes for that session to be granted. But then once it is, the scheduler will actually go ahead, and then it will execute a command, which is like that nginx. And so then it'll start the nginx, and then basically it gives a URL to the user that they can click, and it'll take them directly to that session running on that specific compute resource. Yeah.
Any other questions?
Why is it that the software needs to use both Apache and Nginx?
I get that question a lot. Thank you. So, to be honest, it's not quite clear to me myself why specifically that's there. For me, at least, I can give a justification for why I'm supporting that. It's mostly because that's how Upstream has it. A lot of their tooling is kind of built around using Apache, and I think when they kind of specifically look at Nginx, they kind of see it as more of a reverse proxy than, say, like a web server. And so the reason why I guess they have both is that Apache, that's the main web server component, and then they have the Nginx stage with the custom plugins that they need built in, and then that way, they're not cross-conflicting with say a normal Nginx instance that's well optimized for just being a web server, and then say their custom modified version that's, specifically built for launching both Node.js, Python, and Ruby apps. So that's kind of why they have both, and then they also have a lot of utilities that are built around supporting Apache.
Any other questions? Well, then may we have a round of applause for Jason's excellent
Thank you.
talk.
Thank you.
Well, thank you for that. We have a short break again, and then we come back at the hour for the next talk. Is a good one also.
Yes.
Also in this area.
Yes, high performance OpenStack with
That's right. Okay.
Felipe.
So we'll see you back at the top of the hour.
See you back in about 13 minutes.
Have you gone and talked to people at places like Oak Ridge National Laboratory about things that they do and use this for? Because getting a connection between yourself and the end users is, I would think, very important.
Yes, yes. So we have talked quite a bit with some institutions, so part of our HPC community. We have a lot of folks in there, so we have someone from AMD who hangs out with us. He's responsible for all their GPU driver packaging for Debian and Ubuntu. And we have a lot of other folks too, like our OmniVector. They have a lot of customer use cases they bring to us.
Okay.
And so we're actively seeking those sponsorships, and then I also do go to a few HPC conferences and
Sure,
speak
because
with.
a lot of the high performance computing work goes on systems that have you'll have programs that were originally written 50 years ago.
Yes,
that
yes,
are still in use because a zillion papers have written verifying that they do the right thing.
Yeah.
So they don't want to rewrite that over again.
So that's definitely something we've talked about.
What?
I've never seen that.
Okay.
And so and it's definitely Open Ondemand. It's not you're going to rewrite everything in a common language. The idea is you can access that 50-year-old program through the web rather than having to use the terminal.
Because the system that I know the most about is what's called X-ray crystallography. It's, for example, what was used to do things like figure out the structure of COVID-19 molecules and stuff like that. And you would be astonished as to how many steps there are in the process of doing that. You start out with biologists who are graduate students spending 3 years figuring out to crystallize one particular molecule, because you have to take the crystallized form of the molecule and put it in an X-ray beam, and it produces a lot of patterns of X-ray spots. And that's the part where I am. I'm running the equipment that does that. And then you hand it over to biochemists who now run it through 15 different programs. I saw a flow chart once of all these various programs on the screen, and it's a huge amount of stuff to marshal. And so if you go into that community, you may get resistance because of people who say that, well, we already have programs that know how to marshal all of this.
And so the idea is that we're providing I guess I would look at it as we're helping provide the infrastructure for running those applications. So it's not we're trying to replace core components. The idea is we're trying to make it easier for a lot of these teams, these I guess multidiscipline teams, where you have the biologists and then you have the software engineers who write the code and all that. We want to make it easy for them to just have a platform that they can all work off of with those applications that they have.
But there are places along the way where there are proprietary programs written by closed source stuff that can be the people in question can be very cantankerous to interact with.
Yes, yes.
It's sort of like if you hit them the wrong way on the wrong day, that they may refuse to want to do anything with you.
Yeah, yeah.
Like there's this one particular one that I won't mention because you don't know who it is, but at least a dozen other people have tried over the years to try and replace his code and failed.
Yeah, yeah. Yeah, I mean, that's always going to be a challenge where it's like you have that self-determined bit where like some folks just don't want to work with you, and it's like you gotta take your wins and losses when you can. So it's like, you know, ideally, like we try and have an upstream first policy with Ubuntu HPC, and so like, you know, we've gone to SPAC, we've done some work with them to like get their snaps, so like they recently adopted it upstream. We've also done some work with Open Ondemand. They're very interested in doing that Ubuntu support because they've traditionally been like CentOS 7. So that kind of helps. But like, yeah, we do have to be cognizant that like not everyone wants to deal with us. Some folks are like, well, you know, everything was great with scientific Linux and all that. So
yeah, well, also you also have to deal with the fact that there's large chunks of that community who are now very wedded to Red Hat Enterprise Linux.
Yes, they are. That's the other issue. So that's one market we're trying to penetrate, and so we're hoping that like as folks see that like, oh yeah, look, like this is a nice platform and whatnot, and also like with containers as well.
Yeah, well, some of the hardware vendors and stuff only want to handle maybe enough. You don't even need all the fingers of one hand to list the platforms they're willing to support.
Yeah.
And things like
that. So that's something too, and that's also another thing that we're working on. Where it's like going to these proprietary software vendors. We're like, okay, you use only like Red Hat like 8, but you know, what will it take to get you to also certify Ubuntu? And a lot of the time, it's showing demand from users who want to use those applications on Ubuntu, and then also sometimes it's just providing the technical support as well.
Some of these decisions are made by people in probably high locations in the hierarchy.
Yeah.
You know, people who, do you actually know how X-ray crystallography works, kind of question?
Yeah.
So I wish you well. You have chosen a tall mountain to climb.
Yes, I have. Thank you, though. Thanks for the questions. I appreciate it.
Okay.
Yeah.
While he's getting set up for the talk, I have a pedantic correction for you.
Yeah, what is it?
So, you don't use the Debian rules file. No, here's the thing. So, historically how it worked is through everything in the rules file, the entire make file for the entire package, that was basically the entire structure. In recent years, it's been made a lot simpler by DevHelper. So DevHelper actually has a bunch of scripts that override those files in the rules file. But really, you're looking at DevHelper, not anything else. This is me yelling at a cloud.
to make this full screen?
You should be able to say present slideshow. It takes up the whole screen.
I believe it's because it's Firefox.
Do you have Chrome? Oh no, we use Google. Yeah. There we go. All right, I'm out of here.
Yeah, give me 1 second to get my microphone. Okay. Yep.
Okay, everyone, we're ready for our next talk called OpenStack for High Performance Workloads. And our presenter is Felipe Reyes.
Hello, everyone. So, OpenStack for high performance workloads. So I'm Felipe. I'm software engineer at Canonical. I've been Charm OpenStack PDL at the moment, OpenStack contributor for many years by now. I've contributed not just to Charm OpenStack, but some other upstream OpenStack projects like Nova and Magnum. And the purpose of this presentation is to try to give you the idea that running software in a private cloud doesn't have to be slow. Typically, when you're running programs in a shared environment, you're going to be facing challenges of contention resources, and typically that gives you a bad experience. But OpenStack provides you a bunch of ways so you can mitigate those, and eventually, depending on if you have enough hardware resources, you're going to be having a pretty good experience. So we're going to go through four aspects: what is OpenStack and why it matters, some of the components that compose the OpenStack clouds, what high-performance characteristics have, and what metrics we care about. And we're not going to go too deep on this. It's a presentation on its own, but we're going to take a quick look at what metrics are relevant here. And finally, what configuration options OpenStack have to deal with all these aspects. So what is OpenStack? Set of components that provide common services for a cloud infrastructure. That sounds pretty vague. And if you take a look to the high overview, this is what you're dealing with. An API, a REST API, so you can get bare metal servers, virtual machines, or in OpenStack terms, they are called instances, and containers. You can configure also to get containers. And then you have a shared networking and storage. And there are a bunch of techniques to mitigate all these aspects, so you don't have to compete for them. Now, if we open this nice box that looks pretty simple, you will start getting into this. Like, it can explode very easily, and you start finding a bunch of things like the message queue that allows to have long-running tasks and have things on the back end. Now, this is an incomplete picture. It's part of the installation guide. It has some components that, in the case of Charm OpenStack, we don't have, like Trove and Sahara, but also it's missing some other that are newer and very relevant for OpenStack clouds like Octavia. Octavia is the one that provides you load balancer as a service, and it's pretty critical when you're deploying Kubernetes on top of OpenStack. So now, from all this very large picture, we're going to just pick 3 components, the ones that are more relevant for what we're dealing with here. Now, Nova. Nova is the one that typically you're going to be interacting with. It's the one you are going to be requesting the creation of your instances. It's the one you're going to be interacting with other services on your behalf, because when you are requesting the creation of an instance, you're going to need networking, so you can access it, but you're also going to need some storage. And Nova is capable of doing all this on your behalf. So it's important to mention that Nova itself is not a hypervisor. It's just a control plane. In the backend, it's going to hand off all the specific virtualization to a driver. In our case, it's going to be libvirt and KVM. It's the one that we use by default, and the one that it has most of the features we have interest on. Then you have Cinder. Cinder is taking care of creating the volumes. In our case, we use Ceph by default, but you can use other stuff like LVM, NFS. There are a bunch of drivers, so you can have a specific network appliances that you may have already in your data center, so you can take advantage of those. In the case of Charm OpenStack, we also have support for Pure Storage, NFS, and some others. So you can take a look at our documentation. But Ceph is the good one. Then you have Neutron. Neutron is the one that is going to provide you all the overlay networking. So you can have your own IP space, you can have your own private network on top of your cloud, and it's going to allow your services to talk to each other, no matter which node they're running on. And again, Nova is the one that is going to be creating ports for you. It's going to be attaching those ports to your VMs, and you don't have to talk to Neutron directly. But depending on how sophisticated the network topology that you can define, you may want to create your own subnets, your own ports. If you want instances with multiple ports, you have to do all of that on your own. Nova is going to give you like the typical VM, one NIC, one volume to store your root file system, and that's it. Also, with Neutron, you can model the gateways, and that way you can configure how your network's how your traffic is gonna flow on your network. So we have this is the control plane, and now what we need is to understand what metrics we want to monitor, because when we're gonna be optimizing, we're gonna be caring about the specific things. Not everyone cares about everything. It's just about pros and cons. Now, when it comes to something that you want to perform well, depending on who you are asking to, he's going to be thinking on memory. Someone may be thinking about IOPS, input-output transactions per second. Some people are going to be thinking about throughput. Some others are going to be CPU-bound problems, and some others about latency in case you have a service that you are expecting to serve those requests under a given threshold. Latency is going to be crucial. All of these metrics get interrelated. So every time you're pushing to have CPU optimizations, you may be affecting some others. So you need to be measuring those metrics and and understand how they are being managed. Now, this is a very well-known diagram. This one is from Brendan Gregg. He's a well-known person, having given multiple presentations around performance and observability tools. And this one gives you an idea of, depending on what you want to take a look into in the system, what tools you may have available. So if it's an application, if it's sockets, TCP connections, and so on. So I really recommend visiting Brendan Gregg's website. There are many presentations. He has a book on the topic and all of that. Now, OpenStack configurations. So one of the most easy to set up is host aggregates. So you may have a fleet of nodes, and those nodes may have different properties. And in this case, we are creating a specific that is for nodes that have SSDs. So we want to create a flavor, and the flavor is the one that is going to define what characteristics the instances you're creating will have. And so you create the aggregate, and you will be setting a property, in this case, SSD equals true. And after that, you're going to start adding all the different nodes that have this property. This is all on the administrator side, not a regular user of an OpenStack cloud is going to have access to those, because this is very intimate on your hardware. Then, when you create the flavor, you're going to be hinting that this flavor can only be used when this condition is true, SSD equals true. Now, this allows the Nova scheduler, the one that is going to look for an available hypervisor, to decide where your instance should be created on. And this way, someone who is using your cloud and is seeing, oh, I have the flavor SSD.large, it's going to have 8 gigs of RAM, it's going to be a disk size of 80 gigs, but also it's going to have the guarantee that this disk is going to be created on an SSD. And that way you can manage your different needs. Now, all these, you can do it, in this case, these are just flags, so you can do the same for GPUs, you can do for any hardware aspects that you may care about. Also, if you have different CPU architectures, you care about differentiating about AMD EPICs or in contrast to Xeon for any reason that you may be, it's relevant to your kind of workloads, you can use any of these. Now, the problem with this is that anyone can use this. So anyone who has access to create an instance based on this flavor is going to be taking advantage of these features. But there are many cases where you want to segregate a specific set of hypervisors for a specific project, because the budget was given to that project, so they purchased those nodes. And in those cases, you can also create host aggregates, but in this case, you're filtering by project. And that will give you the guarantee that every instance that this project, in this case, we're addressing it by ID, there are instances are going to be landing on that set of hypervisors. That way, you are no longer competing with the resources with another project. And if your project is something about research, so those nodes are really beefy machines, you are going to be having a better experience. Your instances are going to be, in the end, running much better. All right, so then you're going to start optimizing by CPU. So OpenStack has a series of configuration options. Some of them are available on the command line over the REST API, while some others are only available at the nova.conf file. Now, when you're defining your your instances. In the beginning, we were saying, okay, this instance has 8 virtual CPUs, and that was it. But then, if your workload is more specific and you want to model a specific kind of machines, you're going to start saying, okay, I want a VM that is going to have this number of sockets. Each socket is going to have this number of CPUs, and this number of sockets. Each socket is going to have this number of cores, and then each one of those cores is going to have this number of threads. Now, this allows you for more hardware-aware programs to run in a specific way. Again, this is very intimate on what you are trying to achieve, because then how this maps back to the hardware, to the hypervisor, is going to be relevant. Because if you're putting too many CPU sockets for virtual CPUs, you may have effectively a reduction in your performance, because that doesn't map really well to the hypervisor actual hardware. So, for instance, here we have a flavor that is going to be defining 2 sockets. Each socket is going to have 4 cores, and each core is going to have 2 threads. So if we launch a VM based on this flavor, effectively when we're SSHing into it and we run LSCPU, you're going to be seeing that this machine has 16 CPUs, right? And if you start looking into how this is laid out in the machine, it's going to have this CPU topology. Now, this is all fine. So we can define many sockets, many cores, many threads as we want, but we still have the problem that there is no way to guarantee how this will be running in the hypervisor. The scheduler is going to be moving all these different processes around, and you may be having still like a bad experience from the performance perspective. So then you're going to start defining stricter ways to how these different virtual CPUs are going to be allowed to run. So when you have the CPU policy, you can start saying, okay, the default is shared, right? So the CPU's processes can be floating across all the host cores. Now, if you have a dedicated set, you're going to have that each virtual CPU thread at the hypervisor is going to be allocated to a specific core in that hypervisor. So you're going to have mapping one-to-one. And now it's when you start seeing the benefits of not overcommitting your CPUs. Now you have that those virtual CPUs are actually running on a specific core, so they are going to be running more smoothly. And the thread policy allows you to decide when those virtual CPUs are allowed to run in a CPU, in a physical CPU, that if it has a hyper-threading enabled or not. Because when you have 2 threads running on the same core, there are still some memory shared there. And depending on what you're trying to do, that may not be a good idea. It can have privacy concerns for the workload or performance concerns. Now, then you have NUMA, and you can also model this at the flavor level. Now, NUMA is what allows, it's a way where the memory is not really accessed equally depending on where your task in the kernel is really running. The way it looks is this way. So you have that the memory RAM is associated to a given socket. And so if your program is running here in this socket, you don't see my cursor, okay. So if it's running in this core, for instance, and it's trying to access memory pages that are located in this section, the timing, the latency is going to be larger. So again, depending on your workload and how it's manipulating all this, it's going to be relevant. So OpenStack is going to allow you to define how many NUMA nodes your virtual machines wants you have. By default, it's only one, and it's going to be floating around. But you're going to start making more specific things, like, so I want 2 NUMA nodes, and each NUMA node is going to be composed of this number of CPUs. And then each a given CPU is going to have access to a portion of the memory. So then we can create things like, let me find my cursor. Here it is. So you can create asymmetric definitions. So in this case, we're defining 2 NUMA nodes, and then we are saying that for the CPU 0, we're gonna for the node 0 of the NUMA, we're gonna be assigning 0 and 1 CPUs, and we're gonna be assigning 2 gigs of memory. Then in the other NUMA node, we're gonna be assigning 2, 3, 4, and 5, and we're gonna be assigning 4 gigs of memory. That way, a program that is aware of all these characteristics is going to be able to manage that memory and take advantage of this setup. And this is going to be being translated by the scaler, and when the VM is defined at the libvirt level, it's going to be giving you a good representation so the hardware can be taken advantage of. Now, this is all great. We're trying to map these definitions that are abstract in the flavor and how all those map into libvirt. But we still have the problem where the kernel at the hypervisor level is going to be trying to assign a bunch of other administrative tasks and in cores that we may want to be really using for virtualization. And in those cases, the recommendation is to start using ISO CPUs. So this way, you can, in this case, in this example here, ISO CPUs is a kernel command line option. You are going to be adding it into your graph configuration. So this way, in ISO CPUs equals 0-31, you are saying from the CPU 0 until the 31, don't schedule anything there. So the kernel is not going to be considering those to assign any task. So anything running in the hypervisor, it's going to be only running from the 32 and above. And this gives you the guarantees that any VMs using from the 0 and 31 are really running alone there. They are not competing for resources. They are not going to be being paused to run other administrative things that the hypervisor may be trying to do. All right, so that's all what I have for today. Anyone has any questions?
Thank you. Well, first of all, great talk. Really liked the content. Quite relevant to what I do. But I guess one question that I potentially had is like, I guess, here what you showed is that it's like possible to tune your OpenStack, like your private cloud, to get the best performance possible. But I guess what I'm interested to know is like, how do you maybe like improve the messaging, the documentation? How do you make people like aware of like how to do this performance in like an easy way so that they know that like, oh, this is what I need to do? Because I feel like a common problem is potentially that, folks just like follow a basic tutorial, and once it's deployed, it's like, oh, I'm good to go. I don't need to do anything else. And then when they go run their workloads or something, they're like, oh, this is really slow. This is crap. But that's just because they potentially didn't know how to configure it.
Yeah, that's true. The documentation makes a lot of assumptions. Like, for instance, if you go to the Nova documentation on how to configure NUMA and how to define flavors that take advantage of, it's not going to walk you through on why someone may really want to do that. There is baked in assumption that someone really knows what it's doing. And then you have that, as I was saying at the beginning of the presentation, every time you're taking one of these decisions to push into a given direction to take advantage of your hardware, you are putting in a different position when it comes to launching VMs. So the reason why many of these are not defaults, it's because every time you put an extra constraint in the flavor definition, the scheduler is going to have to work harder to find you in a spot in your fleet of nodes. And depending the number of VMs you may have, and how large your set of hypervisor is, you're going to have more times where the scheduler is really not finding a good place to put your VM, it's just failing and give you an error. So how to make that accessible? Probably try to at least give you pointers on where to read more about certain things like NUMA, how that affects to the programs that are running there. I think some of those links could be made from the Nova documentation to libvirt and Kimo, which is the one that probably explains much better and in more depth how all this lays out back in the hypervisor.
Great, thank you.
I know what you're saying, because a lot of times when you go there, you just assume default works, well, I do. Default works well for me, but I think providing use cases as examples, maybe that will help the users. Because if you have to go rate a lot of man on this and that, there's so many options, right? And we usually try to just quickly get the work done. I mean, I'm working on a user story. I have a time, this is not something you can spend a lot of time on, but I think I like use cases. If you can just list, well, then everybody does something different, right? I'm just saying some of the common uses and give example, what would be the parameters, you put in there or whatnot, and I think that will be helpful, but that require work from the developers like you, right? Oh, I had to think about what would most people do. But that's what I would recommend. Because there's so many different options, right? How do you worked on it for a long time, right? So you know what's the optimum thing to do. But most of us, I don't know about most of us, for people like me, a lot of times, I want something quick, right? I may not have the time to get into details, but seen some use cases, that will help me to determine what should I use, right? So anyway, that's just my suggestion. Or you can get really details on multiple use cases too, right?
I agree with the sentiment behind that idea. The tricky part is that many times people take those examples as if they were golden rules that they can just copy and paste without really understanding. So I remember a good example here where someone was applying, was dropping the file system cache, and they were running it in a cron job, so they were trashing away the performance of the page caching, and they didn't really have a reason. It was something that they just copy and paste from the internet because they said the internet said that this was to improve the performance, but it was under very specific characteristics. And if you don't understand the characteristic of the thing you're running, it's better to stay in the default values.
Okay, I see. So just use it. But then we wouldn't know the real capability of the thing, right? So you're saying we have to think into it in order to use the powerful thing, right?
Only no default works well for everyone.
What?
No default works well for
I
everyone.
know.
Like a lot of those things will make things worse for a lot of people. But they will make things way better for some people.
Yeah, right. That's true for everyone. I know. I know. It's just everybody's different. But my thing is, we're always short of time.
Mhm.
the thing we have to get it done. If it's working, somewhat working, then we just go on, right? So, I know it's hard, unless you get deep into it, so.
So real quick, I saw you using like an M1 as an example up there. If I were to like compare this to say like an M1X large or like any sort of AWS instance, have you guys done a comparison of like, okay, this is an M1, this is an M2, or sorry, this is like an M4 1X large, M4 2X large, whatever, AWS or your favorite cloud provider instance types, and then said, okay, this is what they're doing, this is what we're doing, like get a comparison of performance or anything like that so I can start to understand like the scheduling algorithms you're using or just the assignment algorithms, like how things are happening under the hood and as a cross comparison to other hypervisors and other ways of doing isolation?
Specifically, we haven't ever done that because every cloud is choosing, every private cloud based on OpenStack is choosing different set of hardware because the hardware has been changing over time. Many times they buy a set of nodes in one point in time, and then 1 year later they're getting a different set of hardware because they want to expand. So it's really difficult to say if you apply this set of settings, you're going to be an equivalent experience to AWS Flavor X. Because in the end, all this depends on the hardware you're running more than which setup you have.
Fair. And I guess the other question I have is, when EC2 first started, it was a really big problem with noisy neighbors, like on the same instance. Do you guys, how did you tackle the problem of noisy neighbors in what you're doing here?
This way. Basically, you need to start isolating CPUs. You need to start stop overcommitting the CPU in many times because that's what hurt you the most. Even if you are not really tuning all these aspects, if you say that you're one-to-one in terms of virtual CPUs and actual CPU and physical CPUs, by default, you're going to get a much better experience. But in reality, many private clouds, they want to overcommit because they don't have the budget and they want to get the idea they have a large capacity.
Any other questions?
I'm sorry, what does a noisy neighbor mean in this case? Do you see a degradation in performance or what? In terms of, you're talking about AWS, right? I just don't understand that.
Right.
Or everything is on-prem for my organization, so I don't know what that means. Noisy neighbors.
Same thing. So if you, what he's saying is if you overcommit on your resources,
yeah,
then you may not move everything off of the CPU for one job to move another job onto that same CPU. Like the physical hardware, if it's overcommitted,
oh.
like all of a sudden your RAM is not what you expect it to be.
Oh.
Crashes or you get weird data corruption issues because suddenly somebody else's program, for whatever reason,
I see. I get it now. All right. Okay, thanks. Sorry, that was just a...
No, that was a good clarification because we all have questions like that. Any other questions here? Thank you very much for that.
Thank you.
We have another short break again, so stretch your legs, and we'll come back for our final talk of today on AI. Yes, so that'll be pretty great here at 5.
All right, so for our last talk for today, we are very, very, very lucky to have an expert here who has a really, really cool talk for us. It's called Language Learning Models from Zero to Hero. And so it is my pleasure to introduce Andrea Montano.
Thank you. And I hope you can hear me. Thank you everyone for staying until so late. I know by now we're all thinking of beers and having dinner and all these things. So I'll try to make it interesting for everyone. To start by introducing myself, I'm Andrea Montano. I work with Canonical. I'm an AI product manager. I have a background in data science and machine learning, especially in retails and telcos. But at some point, because I was too frustrated to deal with all the tools, I changed places. I joined the product team in order to build solutions that are actually easy for data scientists, machine learning engineers. This talk is going to be introductory and is going to talk about large language models, as well as how you can benefit from open source. I'm a big believer in open source. I love communities that leverage open source. So let's not make it any longer. So I'll tell you how it all started. It was 2 years ago, ChatGPT popped up. I was about to go on holidays, and I was telling one of my coworkers, I really want to go to the Maldives. I love diving. She said, fine, Andrea, you can go. Just do it. Okay, that's Gen AI, but that's how I got introduced to large language models. And if you're just getting started in this industry, I think there is a lot of confusion between Gen AI, LLMs, and that's all right. But today we'll focus on large language models. And for those who are not familiar with it, they refer to models that use deep learning techniques to capture complex patterns to produce text. They usually train on self-supervised learning, and they are beyond the scene of large transformers. Well, let's look a bit more in depth at them, because large language models are large. They are trained on data sets with many parameters. GPT-3, which was the one that I looked at when I prepared this talk a couple of months ago now, had more than 100 billion parameters. And let me tell you something, GPT-4, it's at least double the size, and it has more parameters. It has also been trained, GPT-3, just to make clear, on 45 terabytes of text. And that's why it's so capable. It has the language part because it mainly operates on human language. And then, of course, it has the models part because they are used to find models or make predictions within the data. Look, whereas we all look at LLMs nowadays, or in the last 2 years, whatever, we are not really at the beginning of this journey. I remember when I started with machine learning, it was 10 years ago, and everyone was telling me, Andrea, you're doing unicorns. But machine learning was also around for quite some time. I think it's the same with LLMs. They became famous a couple of years ago, 2 to 3 years, but the truth is that around in the 900s, or towards the second part of the 900s, people started looking at the idea or exploring the idea of LLMs by building basic rules. As you may imagine, that didn't fly out very well because it was too manual, it was not adaptable, it was not scalable, so they dropped it. In the 2020, it's the year that I think large language models became very popular, and nowadays you have plenty of options that we will talk about in a second. But then, who can use large language models? Do you have a use case? Just raise your hand if you know of a use case that could benefit 2, 3, 4 people. 5, don't be shy. Jason has one as well. So there are plenty of use cases. Some of them are very familiar. We all use ChatGPT, right? And chatbots are familiar, but then the applications go beyond it. You can use it for text generation, story writing, marketing content. You can use it for summarization. I don't know how many of you stay in long meetings. I do. I have 6 hours meetings a day. So if someone can summarize my meeting notes, I'm very happy for that. Translations as well. It's very important and it's useful, especially in environments where English is not your native language or you struggle with it. English is not my native language. And if I'm tired, I might switch to Romanian. I'm not jet lagged anymore, so we're fine. And then last but not least, classification. For example, in marketing, again, there are a lot of sentiment analysis that's being done, and LLMs are important. One thing that I want to say here is that whereas large language models have applications across all industries, from having chatbots in retail who tell you what are the latest offers, to sentiment or to telcos companies who are looking at how you talk about the latest offering to see if they keep it or not, you should always look at the use case. Don't use large language models just for the sake of it. That's not how you should do it. You should start with a problem to solve. What does it bother you every day? Does it bother you that you have to go through 20 pages of meeting notes? Okay, let's summarize them. That's great. But if you just do it for the sake of doing it, it might be fun, but it might not give you results that you're very happy with. That's where it becomes interesting. Large language models versus traditional machine learning. I already told you, I started with machine learning when it was not that nice. I was looking and working especially on structured data. And that's a question that I get often at conferences as well as with customers. Through my role, I get the chance to meet a lot of companies, and most of them say they want to use large language models or they want to do Gen AI, but they have no use case. So I say, why not traditional machine learning? And the question is, what's the difference? Well, LLMs are specialized in NLP, or natural language processing, and they're designed to handle structured data. But however, they're not specialized in image analysis or ranking structured data tasks, for example. And there are other machine learning algorithms and models, such as linear regression, that are more suitable. So the main question is, what do you choose, LLMs or traditional machine learning? It all depends on your use case. It's very easy. However, there are some benefits that LLMs might have, and you have to bear them in mind. On one hand, you get improved performance nowadays. They do get better results on NLP-specific tasks. And often they surpass the traditional approaches that have been on the market. They accelerate the learning, so often you can use them for your use case with leader training or leader optimization to no optimization. And last but not least, they have multilingual capabilities. In Canonical, I think it was 6 months ago, we were playing with some of our colleagues, and we managed to build a chatbot that was answering in Afrikaans. The reason why we tried Afrikaans is because we are South African, and Mark was curious about it. It answered quite correctly, and I said, okay, I'll try it in Romanian as well. It answered in Romanian as well, to the point where I started using characters that are not in the normal English language. In the same area, there are nowadays LLMs specialized in unusual languages, such as Urdu. It's something that picked up very quickly. It's an LLM that was developed, it's open source, it was developed in UAE by a Pakistani startup, and I know about them just because I'm based there. How do you take these LLMs to production, or how do you actually move away from just the idea of, it exists, so I can use it? It's with MLOps. Are you familiar with the concept of MLOps? Let's see. Some people, yes? Okay. I still define it as DevOps for machine learning. And those who have been in the MLOps space for a long time will feel like killing me. But that's the shortest definition. It's a new practice, or it's not that new anymore, and it aims to take machine learning projects to production in a scalable and repeatable manner. But the truth is that I get a lot of complaints. Training is resource heavy. I need a lot of compute power, it's expensive. Yes and no, you're right, but then that's why you can use pre-trained models such as Ollama, for example, or Llama 2. They're trained, you need to optimize them, but that's much cheaper, it requires less resources. Nowadays, you also have the public clouds, for example, that can give you the access to more powerful compute machines. And to maybe put it in context, when we've built our own chatbot, that I will share a bit later, the architecture, it was costing us 50 cents for each half an hour. So it's okay, if you just want to play with it, it's not very expensive. At the same time, you should look at capabilities such as, or features such as GPU sharing, tools such as Volcano, which is open source, are very great for that, as well as the idea of distributed training and using frameworks such as Paddle. Costs are high. That's what companies tell us. It's too expensive. We don't want to do it. We don't want to train our own model. Again, you don't have to train your model. You can just optimize your model. However, there are also things that you can look at. And the most important part is that you can use open source tooling. It enables you to get started at a lower cost. And then as you scale, of course, your cost, or you can invest more in it. And it's very important to mention here that unlike any other innovation that I've seen on the market, AI is fully open source or is naturally open source. There are big communities around it, and the latest tools, latest innovations, they happen in open source communities and in an open source space. Also, you should always think of your long-term strategy and think of hybrid clouds. You start on a public cloud, as I told you, because you don't have enough resources, but then once you want to scale, you can always move on-prem. You can always consider HPC clusters that Jason's talked about, and there's nothing to stop you from that. You start on one cloud, you move towards a hybrid cloud scenario or a multi-cloud scenario, depending on your needs, where you store your data. But that's not all. It's not reproducible, you know? I have a team of 20 data scientists. They all do the same thing. They get a result. They don't know how to get back to it. I think a lot of data science still happens in small black boxes that people don't know about. And that's when you should think of open source tools again. I feel like I'm a broken machine saying open source a million times, but I think that's the answer in the AI space. Tools such as Kubeflow or MLflow enable reproducibility. On one hand, you can have capabilities such as experiment tracking, which is very easy, but then you can also build pipelines, automate your work in order to make it seamless for your teams. That's what I've done at home. I stopped coding at some point, but I still enjoy doing fun things. And it was really after I played with ChatGPT, I said, can I build my own chatbot? It's easy. When you look at it, it all starts with a user who queries something. That query goes into the embeddings model, and then it goes into the OpenSearch, which is basically a vector database where all your prompts are stored. But that it's not all. From there, the data or the search for the similar searches are retrieved, and they going through the open source model, you get an answer. Of course, not all the answers are good, or depending on how niched your topic is, if you ask about something that is not really available on the internet, I'm not sure if that's possible, then the answer might not be accurate, but that's when you look at this. That's when you look at the more real-world example that's designed not just to be your pet projects, but something that people can use. And there are a couple of more capabilities that you need to ensure. On one hand, that you fine-tune or you optimize your open source or your LLM with data that you have. Assuming you want to build a chatbot about your offerings in a telco company. Maybe it's not the best example, but then you should use that data that you have about your offerings, about what customers usually ask to optimize an existing model. At the same time, and then you should also do it in an automated, reliable manner. I know, it updates once a month with the latest data. But then also, you should ensure that similarly, all your data is stored in a vector database. All your searches and prompts are stored in a vector database. And then when a user queries, the answer gets similarly to the other one. So LLMs projects can be done with open source. Everything that I have here is open source. I've done it on my own. I didn't pay much. On one hand, you have open source models, and I think that's what's interesting for those who are familiar with the ML world. Probably they are also familiar with Hugging Faces. That's where you're going to find a lot of models. But then not all of them are LLMs. But then there are also open source tools that can be used to build your own models, to fine-tune existing models. And open source, sorry, no, there we are. Open source large language models, I can give you easily some examples. Llama 2, Mistral, these are the ones that I think are Falcon as well, are the most used ones, have some benefits. It's easy to get started. There is nothing to stop you. I said earlier in the day that Olama is also snapped, but I think we have some technical difficulties here. I don't want to say it, you can try it out, but you might run into some problems. But it's also cost efficient. You don't need to train your model. Training a model on billions of parameters can be expensive. Not everyone can afford it. I couldn't. And also, I wouldn't want to invest my money in that, even if I would have the money, because, I don't know, I would rather go on a holiday than train models and buy resources. It also gives you flexibility, because I'm 100% sure that there is more data available on the internet than you have in your own machine. And then it benefits from community support. I was not an open source enthusiast before I got into the machine learning world. But the truth is that in the ML space, there is really an active community that you can ask, that's very passionate. And then there's also a matter of code transparency. You can always see what goes in, what goes out. At the same time, there are concerns. I'm not going to say that everything is pink and great, because often there are questions about privacy. And especially highly regulated industries have some concerns about it. I can easily think of healthcare, for example. That's why they've been looking at confidential computing as an alternative to further optimize their models. But then there's also lack of support and lack of enterprise support, especially, which can be challenging. And then the learning curve is not that easy. Your first 3 months in the machine learning world are going to be very, very frustrating, I would say. I don't want to disappoint anyone, I don't want to scare anyone, but it's annoying. It's just a completely new world. It's a lot of data. Sometimes, at least when I started, there was not so much compute power, which I would start training something, it dies halfway through. How do I do it? How do I debug it? It can be annoying. And then there are some security risks as well, which are really related to the vulnerabilities that the packages that you use can benefit. There you go. I knew I had a slide with this. It's also interesting to look at LangChain. It's not a large language model per se, it's a framework, but it's widely adopted in this space. Tools. Do we know open source tools that we are using in the machine learning world? Come on. There is one that everyone uses, I'm sure. No? Jupyter Notebooks, no? Okay, yes. I think it all started with Linux and Ubuntu. Then it goes towards Jupyter Notebooks, Python, PyTorch. There are plenty of programming languages and tools. And again, it's easy to get started, which I like it. I know, it's easy to deploy Jupyter Notebooks. Everyone can do it, I guess. Or if they don't do it, again, they look on the community forums and they will find the answers. Even if it fails, it's going to fail a couple of times, but in the end it works. It enables customization. I'm not sure how much, or if you've tried tools that are already made, such as the public cloud solutions, but then they're very rigid. They give you a solution that works well, but if you have different needs, or if you want to try something new, especially if you're in an exploration phase, they're not that flexible. And then it also is not something that in the machine learning world we talk that much. But open source tools give you the ability to contribute. And especially if you're just getting started, or you like contributing, you like making the world a better place, you really can do it. And projects such as Kubeflow, which I'm active in, really appreciate contributors. By contributions, I have to say, I don't really think only of code. I'm one of those that think that code is not the only way to contribute to a project. You can contribute by writing documentation, you can contribute by providing feedback, you can contribute by trying the product and building a nice tutorial. There are plenty of ways to do it. Don't just think of code. Because especially if you want to do data science, it's maybe unlikely that you will want to contribute a lot to how the project is built, but you can provide a lot of feedback. That is very valuable. And that's how I started in the Kubeflow community. I tried to deploy it, and I couldn't. I failed dramatically. So I went on the community chat, and I said, hey, this documentation is outdated. I don't know why it doesn't work. In the end, I think we've learned why, and we also improved it. There are, of course, some downsides, security, lack of support, similar documentation. I just told you what happens, right? Jason told you what happens with the documentation. He thinks that the code is the best documentation, but not everyone knows how to read the code, so documentation is important. But also bug fixing, whereas you can suggest bug fixes, it might take a bit longer. I asked you about tools. Well, when it comes to large language models and tools that can be used, I'll take them one by one. Kubeflow is an end-to-end MLOps platform. It was a project that was started by Google 5-6 years ago. It's quite some time. Now it's part of the Cloud Native Foundation. It's a suite of tools. The way that it was designed, it was to be a suite of famous or leading open source tools that can enhance the machine learning project. So it has Jupyter notebooks integrated for the training part, especially. It has Katib for model optimization. It has Kserve for model serving. And then it has Kubeflow pipelines, which I think are the heart of Kubeflow. And they're really used as MLOps pipelines to automate machine learning workloads. Then you have MLflow, which is used for experiment tracking especially, and model registry. It's, I think, the most famous machine learning tool on the market. It's super easy to use it. It's the thing that whenever you get started, it's easy to install it. It's very intuitive as well. So if you're just looking into something, Jupyter Notebooks plus MLflow, it's the way to go. Then you have Spark for data streaming. And last but not least, OpenSearch, which historically is famous as being a NoSQL database, but it can be used as a vector database. And any project that uses LLMs needs a vector database for storing its prompts. Then when it comes to Canonical and what we do, I do love it. We do have a solution that includes these tools and a couple of others. And they are used really to fine-tune, or what you can do is fine-tune models, benefit from all these components being pre-integrated, upgrading easily and easier as well, updating. But I'll move here. What do you do when you want to scale your project? First thing, and most important one, start with a use case. That's how you get started. You have a problem to solve. Don't think that you'll scale something that you're just doing for fun, because it can work or it cannot work. Think of your users. Whereas now, you're likely to work on your own, on your machine. In 3 years from now, it's likely that you want to have a team of data scientists, and then you want them to be secured, to have clear isolation between their pipelines, for example, and so on. Think of how to optimize your resources. There are some reports that around 70% of the GPUs are underutilized, and that's sad. It's sad and unsustainable. You also have to bear in mind that it takes 6 months nowadays to get a GPU, so what do? Well, use and look for resource schedulers. There are many open source options for that, and then it really enables you to, on one hand, even get started with maybe resources that you have in place, but then also to optimize it in the long term. Look at the reproducibility of your work as well as portability. If you start, especially if you start on a public cloud and you might want to migrate, being able to enable this will help you. Look at the monitoring. I didn't talk much about it, but you should have, and you should enable model monitoring, data monitoring as well, data drift monitoring, because otherwise it might be risky. You might have some malicious friends who try to play negatively with your models. And last but not least, look at the security and compliance. There are plenty of packages that are being used in any machine learning project, from Python to NumPy to Pandas there are many of them, and many of them have vulnerabilities. There are more and more attacks. Last year there was a famous one called ShellTorch, or yeah, I think it was ShellTorch called, or it was against PyTorch, and it really harmed a lot of organizations. Whereas when you have fun, it's okay, especially you want to implement it in your organization, look at the security and compliance requirements. And all in all, have a long-term vision for your machine learning project, either if it's with large language models, either if it uses Gen AI, or it's just a traditional machine learning project, which doesn't look that interesting nowadays. I think it's still very useful. So just to recap, you should get started with a use case using open source tools. Try to be able to, or to enable reproducibility of your experiments, and try to use solutions that run on any environment, whether it's public or private cloud. And then you should always scale with integrated solutions. And once you start scaling, look also for enterprise support. And that was me. That's where you have my contacts tomorrow, Jason. That's our boot number, or the day after. Tomorrow I'll be around if you want to talk more about AI. And I hope I stayed on time. Did I? Yes.
Well, I know we have some questions. Yeah? Oh, come on. That?
No questions, it's okay.
Do you get pushback when you make such a compelling case about machine learning versus LLMs? Because there are some fanboys, right?
Yes, sometimes I do get the pushback, because we do see people wanting to do and to play with the latest and greatest tools on the market, which I'm happy with and I encourage. At the same time, I don't think we should, especially as an organization, we should sell solutions that don't solve a problem. So I usually, when I push back, I try to come back and identify the use cases. It always starts with a problem. If there's no problem, there should not be any machine learning project. Just because your friend does it across the street, you should not do it.
The takeaways I get as a layperson who does not work on either side of that is more cost-effective, more flexible, with more focused results.
Yes.
So as a business owner, I'm like, I have fashion, or I can run my business. It's kind of what I'm getting out of this.
Yes.
And that's probably unfair. Maybe someone's going to argue, but you make a compelling case. Thank you.
I would also, there's a question there, but there is one more thing that I want to add, which is related to sustainability. We don't talk much, and there's reports that started to come up, but if you leave too many GPUs running in one place, they become environmentally unfriendly, and we should also bear that in mind and be very mindful and cautious of it.
Hi, thank you for your presentation. You mentioned OpenSearch a couple of times, and I used to work a lot with Elasticsearch. OpenSearch, as far as I know, is just kind of a fork of that. And I'm wondering how exactly, it doesn't seem like machine learning or AI to me. That's more like parsing, tokenizing, and...
OpenSearch initially was not designed for machine learning use cases. You're right here. And it started once Elasticsearch went closed source. It's used for storing the prompts from prompt engineering on LLM use cases, and that's how it's being used.
Okay, my name's Nathan. Great presentation, thank you. And question is, you touched on like that. I love that multi-layered Venn diagram for machine learning, and then like AI, and then LLMs, and all of that. So, you know, with the kind of the new hotness that is LLMs and everything like that, I'm seeing a lot of people being like, can't we use an LLM for this? When you'd probably want to use something like traditional classification, you know, linear regression or something like that, right? So how would you guide, or how would you kind of solution those conversations? To be like, hey, that's not the right thing for you, in like the zero from hero to maybe you should be a hero in your regression instead of, you know, GPT-4.
Usually, it's a bit of a dance there because, again, most of the people are attracted to work with the latest and greatest tools on the market. However, usually it goes back to their use case, their problem. I give examples of algorithms or similar success stories, as well as timelines. I think when it comes to traditional machine learning, they can get better timelines because it's something that's been studied on the market. So I think it's a lot of consultancy that takes when you want to convince someone what's the right path to go. But as long as you position yourself as the expert in the room and you have the right arguments, which do need preparation, it should be easy.
More questions? Yes.
You mentioned you built your chatbot there in the flow diagram. Do you have that set up as a script, or how can I set that up at home?
With scripting in Inkscape, that's how it can be done.
We do have the code actually open source. I can try to find it after that and I don't know, share it with, I think Nathan probably. Yes. Okay. Yes, we can give access to that. At the same time, you have to bear in mind that the chatbot was really for internal purposes. So some of the questions and some of the things can be fun to play with. Like we used to ask what is Ubuntu Pro and who's the founder of Ubuntu, and it answered correctly in many languages. But then for some other things, it was not very well optimized because we didn't want to. It was more of a pet project that we wanted to have. But I'll share with Nathan the code.
Where do you see this going in the next couple of years?
Oh, I love this question. I always said the future of AI is open source. And I'm not saying this because I'm here. That's what I truly believe. I think in the long run, it's going to be a shift in job roles. We're going to have experts in different industries on AI projects, which is very important. Also, I think that we'll see more companies and more people running or taking their projects to production rather than just having fun and playing around with, which is going to require a lot of upskilling. Better security, better monitoring are just a couple of things that I can think of. Also, I do expect actually to have more sustainability concerns, and it's interesting because I know that, for example, in the telco industry, which was also a very unsustainable industry, they do have projects nowadays to turn on and off the cell towers depending on how they are used. I think in the long run it's going to be the same with machine learning, and I'm excited. I don't know. I'm curious. And also, I think it's going to, as a user, I think it's going to be, in a way or another, commoditized. Like nowadays, we don't see that we get recommendations on Amazon when we buy things, but it's a machine learning algorithm behind it. I think we're going to see more and more applications in our lives that use machine learning, and we won't be like, it's an ML project, but rather it's normal in our lives.
You mentioned that step one was to have a use case. What advice do you have for companies that want to apply LLMs but don't have a use case yet?
No, if you don't have I mean, it's a bit of an unpopular opinion, but I think if you don't have a use case, you should not try it out. But rather try to collaborate with research institutions, universities. That's where you find easy use cases, as well as public sector organizations. I think all organizations across the globe, from very developed countries to maybe less developed countries, are looking to digitalize different parts of their activity. Try to, if you have a company, try to collaborate with them and identify their use case and try to help them out. Don't just do it because you want to do it. I'm still against that.
I'm a statistician. I actually work in public health. And most of our statistical models are used in machine learning. And so with statistical model, they're explainable because they're wrapped under the framework of hypothesis. Like linear regression is actually a hypothesis framework for correlation between predictors or features and outcomes kind of deal. With machine learning models such as, my thesis is actually on trees decision based and all that stuff. It's more empirical based and not much into theory in explaining. Do you see in the future if large language model, or if there are going to be more research in how they work in terms of?
Yes, and there are already papers being published on this topic. I think that explainability of any model is going to be a big topic in the upcoming years. And the main reason for that is that as organizations start adopting and start building their own ML models, there are going to be questions on the decisions that these models take. If you think of a credit risk analysis use case in a financial services institution, if I'm telling to a person, you cannot get this credit, you also need to explain why. And the organization will be eligible to all sorts of sanctions if they cannot explain why. And in order to explain why, they need to actually have an explainable model. And I think that, I know that there are a lot of investments in this area. A lot of papers are being published. I also think that it's still a topic that is not extremely mature. At the same time, open source models are more advanced on it than black boxes that are completely closed source.
I believe we are at time. Is that correct? Yeah. So no doubt more questions, but let's have a round of applause. That was great.
Thank you.
When your talk was submitted, I was excited because I wanted to see what Canonical's up to in this space. I didn't expect such a broad overview with enough details that we could all hook into, presented so cleanly. It was a really great talk. Thank you.
Thank you. One thing that I didn't say is that when it comes to these tools that I had in one of the slides, they're all available by Canonical. You can just go on our website, deploy them, provide our feedback. You can find me on Discourse and Matrix, and not just me, but also the engineering teams behind it. They love the community feedback more, not more than I do, but I interact with a lot of people. They don't interact that much, so they are really excited when they see feedback coming in. If you try them out and have feedback, just reach out to us. We are a message away, and some of us just a couple of miles away as well.
That was great. Thank you. That concludes day one of UbuCon. Tomorrow, we kick off with something very different from today, because today we talked about a lot of big things. We talked about big data, and we talked about big projects. And tomorrow, we start the day with an artist discussion of open source and how it can benefit arts in the community. So that's how we're going to start at 10 o'clock here tomorrow. The day has many great talks, including a hands-on workshop of building apps for Nextcloud. So we're going to have this and more fun tomorrow. I'll see you guys then, 10 o'clock here. Thank you all for coming.